whatever you want to do. Sure.
That's probably about 10 or 15 minutes. You're probably good, but just in case.
And I have my world.
All right. Can anyone hear me? Hello, hello. Welcome to the open source AI track at Scale 23. Your safety and comfort is important to us. So if you feel unsafe at any time, please call our safety number posted around the venue. Our next talk here today is with Stormy. And we're gonna have her talk about, is AI killing open source software? Take it away, Stormy.
Maybe you can hear me now. So I am super excited to be here back at Scale, even despite the loud noise that just went off. It's been a while since I've been here, but I've made a lot of friends and a lot of family here. I've had some great conversations. I see some old friends in the audience. I see people that I hope are new friends. And what I really hope in this presentation is that I start a conversation. I do have to share a story about coming to Scale. When I used to trick my kids into giving me extra hugs when I left for a business trip. I'd be like, I'm going to be gone for 4 days. I'm not going to get any hugs. I need lots of hugs. And then I brought my son to Scale. And he was like, Mom, you get lots of hugs. So I love being here. I love talking to you all. So I have a confession to make. I actually tried to use AI to create my slides. It took me about 10 times longer than if I had created them myself. And it was not a repeatable process the whole time. And it created artifacts that weren't meant to be shared and collaborated on, which I found interesting when trying to give a talk about open source. Like Notebook LM actually had the best slides, but they were all just images. Like I couldn't change the typos, I couldn't change my plan, I couldn't generate a new slide in the same template. So I feel like I got a little bit of the feeling of how it feels to work with some of the AI tools when coding and what it feels like to get some of those PRs full of slop, because I often felt like that when I was asking for a new slide, I got a PR full of slop. I did, and the attribution's a bit wonky. I did check all my facts. I'm pretty sure they're right. But I put all of the articles that I believe I referenced in the slide on a LinkedIn post. And if you're trying to find a particular stat that I reference in the slides, the best tool that I found is take that whole list of URLs and dump it into Notebook LM, Google Notebook LM, and ask it questions, and it will tell you what article it came from. So now, on to, is AI killing open source software? So what I thought was happening is I thought when you used AI to generate some code, I thought one of two things would happen. I thought you would not contribute it because either you would say, I generated that code in that solution in like 30 seconds. So it's really not worth sharing with anyone because anyone can generate it when they want. Or I thought they would say, this isn't my code. Like, I don't know how it works. I didn't write it. How can I put my name on it and contribute it upstream? Turns out I was both right and wrong. I was right for a few people, probably people sitting in this audience, people probably that have been in open source software for a long time. They either don't contribute it because they don't think it's worthwhile or they don't understand it. I actually have a coworker who has a whole bunch of really useful scripts that he wrote in Python, I think, and he wanted to convert them to Rust or something else, and he used an AI tool to do it, and he's like, but I can't put these on my repo because I don't really understand this code very well, and I don't want to say it's mine, and I don't want people to trust it when I don't even know what it does. But the majority of the world went, wow, I can contribute something really meaningful in 30 seconds. Like, I can solve all your problems. You said you have all these issues. I'll just solve them with my AI tool, and I'll submit a pull request. Look how useful I am. Look at what a great contributor I am. How many people here have received a pull request full of slop? Quite a few people. And then the fact that they submitted it, then they didn't understand it, which was not a problem to them when they were submitting it, but when they get asked to maintain it, it's then a problem, and they're like, not mine, I didn't write it. And that's actually a really interesting phenomenon I'm seeing with AI agents. All those AI agents that are out there that you read about in the news, somebody created them, and somebody paid for the tokens for them to run. And yet somehow when the article comes out, it doesn't say Stormy released a rogue AI agent in the world. It says rogue AI agent did this, as if no one had responsibility for it. So before I go on, I really want this to be a conversation, not just in this room, but I want it to be a conversation that you take throughout the rest of Scale and that you take back to your colleagues and to your workplaces, because I think right now we need to solve this problem. AI is fundamentally changing the world, and it's very definitely changing how we develop software and how we work in open source. So I would love for you to turn to one of the people next to you and share, do you think AI is killing open source software? You don't have to say why, but maybe in 30 seconds, yes or no, in your top theme. All right? Turn to the person next to you, maybe introduce yourself, and say, do you think AI is killing open source software? All right, let's come back. I have stats to share that might... All right, let's come back. I have stats to share that might change your mind by the end of the talk one way or the other, or might make you think about it different. But show of hands. How many people's neighbor thought that AI is killing open source software? Maybe about a quarter. And how many people think it's definitely not killing open source software? For sure not. Awesome. I think we all need to work together to figure out how it is going to fit. So one of the examples I wanted to share is curl. If you haven't heard of it, I'm sure you've used it. It's like in billions of devices around the world. And they had a bounty program. They paid a bounty for security fixes. And they only had 7 maintainers on the project. So small project, important project, and they were trying to encourage people to help them support the project and fix security problems. And they were getting, I say 7 here, but it was 7 in 16 hours. So there was one stretch of period that I think was just too much for Daniel, and he got 7 bug submissions, none of which were actually solving a security problem. And they were getting hundreds a week. Oh, and I forgot the numbers. Each pull request took like 3 people to review it and it took them from half an hour to like 3 hours to review it. So each pull request was taking like 2.5 to 10 hours of people time to review, and then like these 7 were not anything they were gonna accept. So it was a huge drain on these 7 people, of which none of them were full-time on the project. So they terminated their bug bounty program. Their bug bounty program that had been going for years, that had paid out in the tens of thousands over those years to different maintainers around the world, contributors around the world, had to be shut down because the financial incentive made it very lucrative for people to submit patches quickly, pull requests, in hope of receiving that money. So I think this is an extreme example because there was money involved, but I think it is also happening at other levels. And there's a paradox here. Sorry, I ran it through another AI tool this morning, and it did something really funky with my slides now that I'm looking at them. So 84% of developers admit that they're using an AI tool. Oh, mine are just going off. You guys are okay. 84% of developers are using AI tools, but the trust is falling in them. So even though they're using them, they're getting more and more wary of the results that are coming out. But they're not using them any less. We're continuing to use them more and more. I think partially because they're really useful in some cases, and partially because we're really curious about how to use them. But we're getting more skeptical of the results that they put out. And the thing that people are saying is that it's almost right. And if you just want an experiment, try to run your slides through an AI. Like, they're almost perfect, and then there's like a typo, and then you go try to fix the typo, and the whole thing falls apart. So a lot of the things that come back look good at first glance, and then don't work. I was talking to someone yesterday who's actually in a presentation I was giving, and he said internally in their company, they have no AI guidelines, and people are using AI to generate code, and then they're submitting it, and they don't even know AI was involved until something goes wrong. Something goes funky. And then they go and they scrutinize the code a little more carefully, and they realize it's kind of strange and it's kind of weird. So there's sometimes a very subtle nuance to it when it goes wrong. So 66% of developers are frustrated that it's almost right, and 45% say it takes longer to debug the AI code than it takes to debug code written by a human. And then they did a study on the productivity, and what I thought was really interesting in this study is they asked a bunch of people, does AI make developers more productive? And everybody said it made developers more productive. But it was divided into the developers themselves, who were the most pessimistic about it. Then I think there was managers or some type of, role like that. And then there was economists. And the economists were the 39%. The economists were super bullish on the fact that AI was going to make developers more productive. But if you take an experienced developer, not a new developer, an experienced developer, it actually makes them 19% slower. It's because they have to slow down to review the code. So if you look at the overall life cycle, they're actually producing code more slowly. Now, I think it's really interesting when you bring up, is AI killing software developer jobs? Is AI killing open source software? Most of us got into this because we like writing code, the actual coding of it. And it seems like that's the part that the AI tools do the best. They do it the fastest. And so then we are doing the other parts of the job, the parts that we might have called product management before, or the parts that we might have called QA. Or product gathering, or going out and talking to customers. So it seems like it's doing the part of the job that was most enjoyable before. It's also creating a lot of technical debt. So when you look at, and all of these are based on studies, which I apologize are not referenced on the slide, but they are in my list of URLs on LinkedIn. It's introducing a lot of technical debt into the code. So overall issues, there's like 1.7 times more issues. It makes the code harder to read, and it has logic flaws often in the code. And all of this is coming. Like, I think AI is fascinating, it's fun, it's changing the world. I'm super excited about where we're going, but it is changing open source software at a time when maintainer debt and maintainer morale is particularly low. There's been a lot of studies, a lot of surveys about maintainers and how there's a few of them maintaining software for a lot of people in a lot of the world. So I think this was from a Tidelift study. 60% of developers are unpaid, 60% have considered quitting, and 44% saying they're citing burnout. And so we're introducing this world of AI with all of these like slop pull requests and all of this to people that are already maxed out. So it's not like they're not excited about AI. It's not like they couldn't figure out what to do with it if they had time to consider it. It's the fact that they already have a full-time job, are trying to maintain this project that is super critical for the world, and the world is changing, and we haven't given them any time to figure out how to deal with it or to learn these tools themselves before they have to set policies. How many people kind of commiserate with that feeling? I feel it just at work. You're supposed to use AI, but how? So what some projects have done is just create new governance to deal with this AI stuff. It's the tool we've had for a long time. You can set a lot of rules and a lot of ways of best practice by setting governance. So some of them just outright ban it. They're a little worried about, or a lot worried about the provenance of the code. Where did it come from? What license did if it's suggesting a piece of code, where did it learn how to code like that? Did it copy it from somewhere else? What license did that original code have? So they're worried about the copyright. They're worried about the quality, which I talked about a little bit. And they're worried about the ethics. I even saw someone, so I was talking to someone who said that they got a huge pull request. I'm going to talk about a best practice. One of the projects actually just constrained the number of lines that can be in your first pull request. Like if we don't know you, your first pull request has to be short. Because anyone who's asked a chatbot for code for anything knows they're very verbose. And then it just makes it more hard to make sure you understand it and that you know what it's doing. So the first pull request has to be short. So I was talking to someone at a project, and he said someone rewrote a substantial part of the code that needed to be rewritten. Like it had known performance issues. And they rewrote it, and they submitted this huge pull request. And they were very open and honest that they had used AI to do it, but they said, I'm comfortable, I understand it, it works, here you go. And the project's response was, well, why don't you just give us the prompt that you used and we'll recreate the code that you submitted. And I thought that was really interesting. So the code was no longer the valuable part of it. It was like, how did you create it? And one of the reasonings for that is that if you used AI to create that code, is it copyrightable at all? Can we put a license on it? So there's some questions to be answered. What I found really funny is when you ask developers if they used AI, 95.2% of them said that they used AI. If you ask them if they disclosed that in the pull request that they did or in the README for their project, only 29.5% of them admitted to using AI when they submitted that pull request. So that makes it even harder to set a policy about what you'll do around AI coding tools. And you can't ask AI if it wrote it. I gave it a blog post from like 15 years ago, and I said, did you write this? And it said, yes, I wrote that. And I was like, no, I wrote that. Oh, I'm sorry. You're right. I'm wrong. I also thought it was really interesting that whether people were transparent about their tool or not depended on which tool they used. So 80% of Claude users disclosed that they had used Claude to write that code, and only 9% of GitHub Copilot users disclosed that. Part of that discrepancy, maybe a large part of that discrepancy, is in the tools themselves. So Claude tries to submit code that says that Claude was involved, and GitHub Copilot, the way it works in VS Code, doesn't add anything to say that it helped out. But even beyond that, people are more likely to disclose it if they're using Claude. So another policy is that instead of just banning AI-generated code, they consider it tainted and it has to go through more review before it's accepted. So it's like, we don't really know what this is, we don't know what it means for the project, but we know we need to take a little more time to consider it. So other responses besides just banning or putting it into quarantine were requiring people to attribute code, but we know that compliance is not very good based on that one study. I talked about prohibiting large patches as your first pull request, so requiring people to submit small patches or pull requests until they're trusted. Some projects have actually closed down all commits from anyone who's not already a maintainer. So they're like, it's still open source, you can still use it, you can still fork it, you can still do what you want, but we are only taking changes from the people that we know that are already involved in the project. I think that's dangerous for open source software moving forward. And then others are requiring you to manually attest that you created all the code that you're submitting or that you understand all the code that you're submitting. So I don't have a slide for this, but one of the things that I think is really interesting is how will new developers get involved in open source software in this current model with AI? So if you're learning, I imagine anyone that is writing code is learning with an AI tool. You ask it, what does this code do? Or how do I do this? Or you look at the prompts that it suggests. So if you're starting to write code, you're going to use an AI tool. And if you're not allowed to submit that to a project, how are you going to get involved? So yesterday, 3 people separately and independently suggested that maybe instead of having people solve easy to fix first bugs, all the GNOME love type projects, that maybe we start them off on reviewing code. Most people learn first by looking at things that have already been created. Maybe the path into open source software is no longer submit small patches that work. Maybe the path in is you have to review 5 pull requests, and you don't get to merge them, but you have to submit your feedback, and other people will also do it. So I'm curious what you all think. Do you think AI is changing how people get involved in open source software? Like if you were a new developer, maybe you are a new developer, how are people, do you think the current model is going to work? And we can either share with the person next to you, or I think we have a mic, we could get people's ideas. But how do you think it's, first of all, show of hands, do you think AI is changing the way people get involved in open source software? Awesome, everybody. You want to share a couple of those? We have a mic here or you can shout out and I can repeat it. Anybody want to share how they think it's changing? Right.
Yeah, my comment is, what's the point of trying to get involved with an open source project if you're just going to use AI to submit slop? I mean, why are you even wasting your time with it?
Yeah, I have that same question, because like I said, I thought that you wouldn't submit it because you didn't write it or it wasn't worth submitting. But I think people are doing it to they think that's what they're supposed to do. They think they're doing it to try to be helpful. They're doing it to try to become a maintainer because that's kind of the path we've set for them. I am curious about that if people have ideas, because if we understood the motivation, maybe we could help prevent slop from coming in. I think there was one back at the table back there.
I don't have an answer to the slop question, but I'm part of the PostgreSQL community, and I feel like the AI sort of world for us, we have always struggled to reach new users. We've always struggled to get, people who want to use our tool easier access to it. So I think while there's kind of a lot of issues with the contribution, this is just such a huge opportunity for any open source project to really reach a huge and diverse audience that we have struggled to reach in the past. And so I think while I do think maintainers are going to struggle to sort of manage the inbound flux and kind of manage the projects under this load, the rest of us in these communities need to kind of view it as an opportunity too.
And what do you think about AI reaches more people?
I think it just level sets, right? Like there's just the bar to do anything is so much lower. Like even the bar to contribute to open source is so much lower now. Like, where just for example, like if you were going to contribute to an open commit fest for PostgreSQL today and didn't use AI, like compiling software from scratch is not easy, right? Unless you're really handy with the command line, this product really deeply, that's a tall order, right? But now, you can just ask for help to compile all the software. So like just in terms of lowering the bar for people that want to use this and contribute to it with good intention, right?
That's a really good point, because I feel like the bar to get started in any project has kept going up over the last 30 years. Like you used to be able to quickly install everything on your desktop in a few moments, and now you need all these dependencies and libraries, and yes, great point. So we should be welcoming all of these people trying to contribute slop. We just need to help educate them on how best to get involved.
The idea that I heard from one of the maintainers was to solve for this comprehension debt problem is you pop up, again, AI-generated pop-up quizzes about the code before anybody can contribute to that code. So whether it's, and it's all AI-generated, right? So you say, okay, here's a snippet of code, here's a quiz about how you understood that code. And again, that quiz can be AI-generated, which scans the code, pops up a quiz in line, and once you pass through a certain bunch of pop-up quizzes, then only you can contribute or do whatever, fix a bug, a security issue, whatever, right? So solving this comprehension debt problem that we are talking about, this is the best idea I've heard so far. I'm here to hear other ideas.
I love the idea. Use AI to give them a quiz. I'm having two kids one who just graduated and one who's a student still. I think they're going to use AI to answer the quiz, but yeah. So we'll take two more, and then I will have plenty of time for people to contribute. Two more here.
I can tell you what I've learned over the years using Code Assistant since GPT-3 religiously. Having really good guardrails, when we have DevOps Day right here, really good guardrails, CI checks, static analysis, extremely clear requirements. We now have to think all of ourselves as managers, managing a team of agents. So being able to really describe, and then again, the tools, and then also the skills or the agents.md, whatever flavor you're using, having all of that in the process, and then having all of the user acceptance testing and everything run by the agent to then demonstrate with artifacts in the pull requests, so a human can go in there and they've dumbed it down. Having all of that end to end, I've seen, especially with an Opus 4.6 thinking model, it's just as good as a dev as 10 years of experience, in my opinion, what I've seen personally.
So using AI to set up lots of structure to accept things.
Obviously,
yeah.
with human in the loop,
yeah.
that's observing all of that structure, yeah.
Yeah. One more. I think there's one here too.
I was actually going to ask pretty much that question. Are you aware of open source projects that have been using AI tools to set up those barriers? AI tools are really good at templating. They need, obviously, some work afterwards, but it seems to me that using AI to battle AI is kind of a starting point, at the very least.
Yes, and I think I don't have any great examples of someone who's done it end-to-end, but definitely projects are adopting it more. So I think the answer is, you all just given the answer. It needs to be more than governance. It needs to be processes. It needs to be tools. We can't just describe our way out of this one with accept AI, don't accept AI. We actually have to use AI to set up processes and things in place to figure out how we can use the tools better to get better results. So I think this is what we heard here, but this is using AI to help you in the project itself. And I think it's the next slide. Yeah, so I think one of the things that is true is that the more you create the process and the guidelines and the descriptions of the tests, the more you will help AI not submit slop as well. So if you're developing really good documentation, if you are describing the tests that need to pass at the end, the AI tools are learning off of that as well, and they can follow it most of the time. They might say, "Oh, I'm sorry, I didn't know that," but they can learn from the documentation that you put in place too. So it's useful both for the new developer as well as for the AI tools that they are using and that you are using to contribute. So kind of three areas that I think people are using AI right now, and there's probably others and other ways that we should be using it, is finding bugs. AI is really good at doing things like finding duplicates, finding duplicate pull requests, enforcing the rules. It's really good at those very specific tasks. It's also been really useful to a lot of projects in triaging bugs and pull requests that come in. So it can quickly scan a lot of code or a lot of bugs. I talked to someone the other day who is using Strands, AWS Strands is an open source software project to create agents. And he uses it for coding as well, but he has an agent that runs first thing in the morning, runs through all of the pull requests his project has gotten, runs through all his email, runs through all his Slack, recommends actions in each of those cases, and tells him the top most important 3 things it thinks he should look at first in the morning. So it's like a personal assistant that's not only triaging your calendar, but also giving you answers and writing your emails for you. He doesn't have it doing it for him, he just has it generating the report for him. And then pretty much everyone, not everyone, over a third of developers for sure, are using AI to learn more. I personally use AI this way all the time. I feel like I'm constantly being thrown a new technical term or a new project that people act like I should have heard of it and know what it does. And so I discreetly pull out my phone and I say, what is this thing and why is it cool and what does it do? So I think people are using AI that same way in code bases. You know, what does this piece of code do? How could I write it better? What other ways should I be thinking of? So we had an idea there. Any other ideas where we should be using AI in our projects, or where you're using it already in a way that you think has been really useful to you? Anybody want to share? Yep. Sorry, you didn't know you were going to get your exercise today.
AI is very helpful at explaining the code to me. If I don't understand a certain area, just like, hey, how does this work? What's the key files here? Or what's the path of the data structure through here? Like teaching me, because docs sometimes lag and are incorrect.
And to the Postgres example earlier, I tried, when I generated this version of the slides with a Claude skill, and I took a clean machine that didn't have anything installed on it, was not logged into GitHub, and I said, install this, I said, use this skill to create the slides. And it installed everything for me, asked for, asked at each stage, and generated slides, and I didn't have to learn how it all worked, which is not learning, but any other? Yep. If you shout it, I can repeat it too, but I'll wait. We'll wait for that. Right there in the middle.
Yeah, I'm an open source maintainer for OpenTelemetry, and we use it extensively to write our own code. Maintainers with AI are a very powerful power because even if it writes slop, you are there to correct it. But more importantly, all my demos for the conferences are now written by AI because it takes like 10 minutes to write the whole demo that took maybe a day or two before.
Yeah. We'll take one more.
I've noticed that AI is really good at debugging programs. Like, if I have a single character missing, AI is really good at spotting that.
Yeah, it's really good at debugging code. Absolutely. Or telling you like what went wrong. So this is the point of like, we used to have people that started coding by doing a good first issue, and that's not really working right now. So right now, if you put out a good first issue and you offer to pay for it, like curl was with the security issues, you're going to get a lot of slop. If you put out good first issue, maybe you don't get a lot of slop, but for sure the people that are trying to solve those good first issues who do not know how to code, for sure they are using AI tools. And they probably don't yet have the experience to like really review that AI code. When I ask AI for help for some things, like it does things I don't understand, I can ask it how it did it, but I'm still a beginner. I'm still learning, and the AI is still the expert. So if the AI is making mistakes and teaching me wrong, I'm not going to be able to correct it. I'm not even going to realize it. So I think we really need to figure out a new way to help developers get started, not just in open source software, but kind of in coding in general. And we need to have a path for them that walks them through how to do that. So the one I've heard 3 times so far in the last couple days is that we should have them reviewing PRs instead of creating PRs. Any other ideas for how people should get involved? Like, how would you suggest, right back there? The recording doesn't pick it up and the whole room can't hear.
Sorry. Okay, so I think it'd be actually pretty valuable to have a set of prompts or scripts that they could then run against the code before they commit the code. Things like, is it API stable against the original code if that's important? Or does it like manage to maintain like, is it, what bugs might it have? Like actually make the AI at least interrogate the code. Because because even when I write my own code, I will have AI interrogate my code sometimes too. Almost like a reviewer.
So having criteria that they have to meet in the form of AI prompts, but you would still have them submitting code. Any other ideas? There's... Is this the story you're going to share with me?
No, I was going to do that later.
Okay.
Meta stuff about the project. So for example, a lot of the tools work best when they are using specs. So like my org has 50 repos in it, and I needed consistent GitHub labels, right? So I had it generate a basic one, and then the people went, and then they fixed it up. And then we didn't have to write a script. We just tell Copilot, go make this true, and it worked. But now we have a person who's like, really loves to like categorize issues, and then that helps them create an issue triage guide and so on and so forth. So it's not just code, it's also like, I just want to say the meta stuff of the project is also useful.
So tagging the meta things that you have as good first projects? Cool.
Because they have to work.
Yep.
I think the real problem we're trying to solve here is the trust of the people that are submitting code, and like that's, you know, something that we've had to deal with since the beginning of open source software. And one of the things that I would lean into is ways we can actually build trust between people, less about what the code produces. So community meetings, you know, talking with people, you know, either synchronously or asynchronously, because it doesn't matter what tools you put up and what barriers you put in the way. People are just going to build AI tools to get around that. So you say, hey, do code reviews. Well, people are just going to do AI slop code reviews, right? So it's not the code that's really the important part. It's the people that are the important part.
It's a really good point. And the communities, people have always been the heart of it. We'll do one more right here.
I think another good way would be to have people come in and reproduce bug reports, you know, try it out, especially if it's a different architecture, different operating system, or whatever. But just that way, when the maintainers go to fix it, they've got a broader pool than that original bug report, which may or may not have, you know, complete information, and can kind of get a better sense of where the boundaries of the bug lies.
It's a good one. So enhancing the PR and reproducing it with reproducible test guidelines, that's good. Actually, early in my coding career, like in high school, I would take 2-line code programs that people had stuffed like everything they could into 2 lines and then try to pull them apart, and I learned a lot that way. I was going to say something. Oh, on the people thing, I went to an AI event where they were saying it was really important for us to figure out who is a human and who is an AI agent, and they wanted us all to walk around with the software on our phone and like do the swapping of identity thing to create a trusted network. I saw a few flaws in it, but it was an interesting concept. So I already gave the stat. So, you know, learning is super important. A super important use of AI. And I've been asking this the whole talk instead of at the end, but I think it's really important to think about what we can do. I think one thing that came across as the best practice in multiple studies and multiple blog posts that I read was the documentation, and I think we touched on that a couple times from people in the audience. It's really important to document, you know, the tests that have to pass, how you want people to contribute, and it's good not just for people that want to join your project, for people learning about projects, but it's also good for the AI agents themselves. I've also had a lot of conversations lately about AI agents that are ignoring the rules that have been set for them, and what does that mean? And I really feel like that's a bug that should go back to the provider of the AI tool. If they are giving you an agent's MD file format that they say that their agents and their model are then going to listen to, and it's ignoring it, I personally feel like that's a bug, not a hallucination or not something that we should try to work around. But I may not be proven right in the long term, but I think we have to have models where the agents actually obey the guidelines that you have set out for them. Maybe that's too old school. You know, code used to be you wrote it and it did exactly what you thought it did, or it had a bug and you fixed it. And AI tools in general are much more unreproducible. Like they tend to generate different output every single time. And I think that's hard for some of us like me that come from a coding background and we expect code to do exactly what we think it's supposed to do every single time. I feel like we're entering a world that's more like medicine. So in the medical world, people come in and they say have a stomach ache. It's really hard to reproduce it they're in the office, like maybe they say they have a stomach ache, you know, every other day, but they don't have one today. It's much more of an art than like a deterministic science. And if you're interested in medicine, it turns out surgery is the most surgery is the branch of medicine that is most deterministic, and surgeons improve more than other doctors because they get immediate feedback on what went wrong and right in the thing that they just did. But I feel like coding is like surgery, and now it's turning into something more like general practitioners, but maybe that's a bad analogy. Another area that I think is really important is, and I think it's changing open source software in general, is the dependencies. So there's definitely a push right now to reduce your dependencies, and there's even a debate about whether a best practice should be not to depend on small libraries. So those tools like curl, or like, I think I have another one here, example, blobutil has been super useful. People have used it forever. People got, and now the AI can just generate code that does that in 30 seconds. Some people are saying that's more secure, because if you don't have a dependency, that's one less security hole for you. If there's a problem with it, it's not gonna percolate to like all of the software in the world. But the argument has always been that it's more secure to use the dependency because it's been vetted and tested by all of those millions of people. And if you're introducing new code that does what that dependency did, you are more likely to introduce more bugs. But I've seen this as an active debate in many different situations. So some people are advocating for less dependencies, and whereas the traditional advice has always been depend on things so you're not introducing more bugs. I think the reason I included it here is not as a coding best practice, that's not what this talk is about, but as I think this is changing open source software. I think a lot of people got involved in open source software because they wrote a small piece of useful code. And they put it out there and they shared it, and a lot of people found it useful. It got improved, it got enhanced. It still remains small, it's done, but that was their entry into open source software. And that's how they got known, and that's how they started working on other pieces of software and got jobs. And so if we take away those small utilities, are we removing one path to entry to open source software? Not necessarily bad, but what's gonna replace it? How do people get involved? How do they get started? Another thing I think we need to do, whether or not you remove your dependencies, is support open source software. I think now more than ever, it's important to call out to all of the users and all of the companies that are using and depending on open source software to contribute back. Hire those people, allow them to work upstream, contribute to the foundations, contribute to GitHub sponsors. However you want to do it, I think it's important to pour funding into the people that are working on your software. We know from surveys that they tend to put more time into it and are able to create more secure software when they have more funding that enables them to do that. I think it's also really important to submit quality bug reports. So if you find one, don't just use AI to generate it, or maybe make your new users go and make sure that the bug reports are of high quality. Contribute yourself to open source software. And then if you use an AI-assisted tool, even if it's really hard to say, Claude helped me write this, or Copilot helped me write this, or Cura helped me write this, I would go ahead and enter that. I think it's important information for us as we figure out what we do next to know what type of code is being generated with AI being used with it. And I wish there was a more nuanced way to say, AI generated most of this, or AI helped me review this, or AI suggested changes. I think that would also be good data. So the question is AI killing open source? I had you share with the people next to you what you thought. I'm gonna say I don't think so. I don't think AI is killing open source software. I think I'll be back at Scale in another 8 or 10 years, and we'll still be talking about open source software. I do think that AI is creating noise. I think it's changing the reasons why people contribute to open source software. I think they're shifting slightly. I think it's changing the type of project that has been successful. So it's going to be less of the blob utils, and it's going to be more of like the Kubernetes and the more complicated programs. I think it's going to be this influx of AI and these new tools are going to be really time consuming for all of us in the room in the short term. Like, we are going to have to invest time in figuring out how it works in our flow. I think it'll be time well spent. I think AI will accelerate everything, but we need to spend some time making sure it accelerates it the way we want it to. So I think it's changing the way we create software, not just open source software, but all software, obviously. And I think we in the room that care about collaboration and working together and building on the work of others need to make sure that we set up structures where it can help us collaborate, not just help us create. So what I would love you all to do is turn to that person next to you or a different person, introduce yourself if you didn't know their name from before, and do you still have the same answer? Is AI killing open source software? You too. All right, the 30-second warning. All right, so show of hands, how many people changed their minds? How many people had different answer? Really curious. What were you could start? You have the microphone, and then if you could, but you can start. You raised your hand, right? Yeah, you.
Yeah, so like I've seen so much AI slop, and I've like had to de-slopify so much code that was like almost feels like it was vibe coded. But I found out in my process of de-slopifying it, it was very handy to use AI to do that. So I have done some meta prompting, and using those templates for prompts that I'm generating, I've been like noticing myself, okay, I guess now is a good time to add more documentation for developers. Like really spell it out as if they were a junior dev coming into the project. And then the AI reads it. It's like, oh, let's do that. And so I'm starting to see more, oh, this is useful.
Awesome. You said you also changed your mind?
Thank you. Well, a little bit yes, also because now I see how it lowers the barrier for people to start contributing to open source projects. Me, myself, I felt brave enough to start contributing projects for things I knew I was good at, but for projects I was not familiar with. But I have an open question. Okay, AI is not killing open source now, but AI is also models running on someone else's machine, and they are cheap now for the same reason Amazon was cheaper like 10 years ago. What happens to open source once projects that got saved by AI, projects that got better by AI, start losing contributors because, let's say, AI models start to be too expensive to use? That's my question. Will it kill later?
Yeah, I think that's an interesting question and probably a whole nother talk. I've had that conversation. Is AI going to get more expensive or less expensive? Are we subsidizing it now, or will the cost go down? I personally think the cost will go down, but the demand will go up, so they'll all even out. But yes, very interesting question. Will it get too expensive?
I have a question. So we see in Grafana, I work for Grafana, in Grafana community that our number of people who join the community goes down, to reflect what the previous person was saying. We have a lower number of contributors to OpenTelemetry. And the economy is kind of bad, the industry is kind of bad, but also AI. And it's killing the supply of contributors, so we don't have succession for maintainers. Do we see it in other communities? Do we see, do we know if it happens because of AI or because of the economy and the industry state?
That's interesting because I kind of feel like Postgres said the opposite, that they're getting more people because of AI. So a show of hands, how many people are seeing more new contributors because of AI? So a handful. And how many people are seeing less contributors because of some unknown reason, AI, economy, something? A couple. Okay. I don't know if we have a big enough pool there to come up with a question, but that's definitely interesting. Anybody else change? Yep.
Oh, sorry. I had a question generally about one of the earlier topics. You were mentioning that some of the projects are concerned that there may be no copyright on the contributions coming in. Some of my colleagues at Software Freedom Conservancy recently published an analysis of the Thaler decision from the DC Circuit. And they found that there were a number of good points related to that. And I was just wondering if you had any thoughts on the Thaler v. Perlmutter case, and whether that's good news or bad news for open source.
So to be honest, I haven't read the case or the Software Freedom Conservancy's post, but I will go do that. So I don't have an opinion at the moment. So I think we can open it to general questions as well. No, go ahead, we'll take that one. We'll open it to general questions as well. I just wanted to leave it with, I think the world is changing. I think AI is going to change how we work, and I think we very much actively need to be talking about it and sharing, just like we always have, about what works in order to make sure open source software and collaborating works.
I think one thing to consider is that before all this AI, with a lot of code being written by humans, the libraries people were using and the projects they were using, they actually read the documentation for them and they got familiar with these projects, and that made them want to contribute to these projects, which added contributors. But with AI, you don't directly interface with the documentation or the project. You just access it through the AI model, so you don't actually feel or get involved with the project you're using, and that results in less contributors.
Yeah, that's a really good point, that AI is making it just easier to consume it without getting you involved in the project. So
Hi, I just wanted to follow up on one of your last slides. You said it may be that certain projects are going to go away and certain projects are going to succeed and they'll be like more successful. You gave example Kubernetes project, and you said maybe small tools won't be around, and I didn't quite follow the argument, so I wanted to go deeper on that. It sounded like maybe Kubernetes large complex project, that's not going to be implemented by AI tools. Smaller libraries might, but that doesn't sound like a permanent solution because these tools are going to get more complex. AI coding agents are going to get more capable. Maybe someday someone's crazy enough to re-implement Kubernetes using that, and then...
It's possible. I don't have a crystal ball.
Did I get the argument right, though, I guess?
What?
I just want to know if I got the argument right. I didn't quite follow.
So the argument in the short term is that the small things are just so easy for AI just to generate that solution already. They've shown that they can do that, the AI agents. The large things, I think, especially things that are a service or more complicated, like Kubernetes, I mean, I'm probably not going to ask my AI tool to create Kubernetes for me, right? The response right now would be so many questions for me that I would have no idea how to answer. So maybe that will change. I think we're just discovering, I think any major technology that has been introduced into society has changed the type of jobs, the type of work, the type of the way we live, and we're just figuring this one out. This is the new one. We'll take one more question, and then I really hope that you all, okay, we'll take two more questions, and then I really hope that you all continue this conversation and continue to help find solutions.
Not a question specifically, but a focusing that I've noticed as a result of this conversation. At what point does it cease being slop, right? I don't think there's a yes-no answer to the whole question, but what I think falls out of this is what really is the difference between good AI code that passes the bar of slop, whatever that is, versus some new contributor. Hey, this is my first programming language. Here's my first my first commit. I think that there's overlap between the two of those. And so ultimately, the deeper question that's going to have to be answered is, what does slop look like for my project? And again, for my specific project, what are the risks of not understanding the code? If I'm just making some basic CSV parser, if I don't understand that thing, who cares? Right, if I'm making a medical device, I better understand every little bit and bob in there. So I don't know that it's necessarily a always yes, always no, but I do think that there's going to have to be a lot of conversation about what does my project need and how does my project differ from other projects. And from there, governance and all of that falls out, I think.
Agreed, that each project will need to define it. You've got someone behind you that wants to say something.
In regards to open source, the other interesting thing to me is right now a lot of open source projects are inputs into AI models. And the interesting long-term effect of that is how will that impact people wanting to make things open source? Because at that point, hey, this cool, neat thing, now I'm just another input for the next AI model. It'll be an interesting thing from my perspective.
Agreed. Thank you all for coming. Thank you all for participating, and continue the conversations.
So much for your talk. I really appreciate it.
Whoops.
Hello, hello, hello. Welcome, everybody. This is Scale 23. We have our open source AI track here in this room right now. Your safety and comfort is important to us at Scale 23. So if you feel unsafe at any time, please call our safety number posted all around the venue. Our next talk is from Greg Schoeninger. He is the founder and CEO of Oxen AI. And he's going to give this speak about Hollywood and open source. Please give a round of applause for Greg.
All right. Can you hear me? Yeah? Sounds good. Well, thanks for joining right before lunch. I think this will be a fun one, being based here in LA, and how these open source video models are helping Hollywood, or potentially hurting them in different ways, but we can dive into both of those aspects. And we're going to be working from a real world problem that we helped solve of a wrong jacket that was in the scene after they had done the shoot with all of the actors. And while we can't show the real movie that we did this for, we can walk you through a fake example of Pulp Fiction, and we're going to swap out the jacket on Samuel L. Jackson and show you how we used open models throughout the whole process to make this happen. And this is an expensive problem. If you make this mistake on set, reshoots are expensive. You have to pay, I mean, depending on what actors you have to pay their day rates, all the people involved, the sets, the location, the costumes, like bringing everybody back just to redo that 5-second clip or 30-second scene, pretty expensive. You can do this in post with visual effects, but that also is pretty time intensive. You have to build all the 3D models, all the materials, all this kind of stuff. It can take a pretty long time. And so the question here is, can AI become a new tool in our tool belt for VFX? And I think that's a good way to frame the use of AI in Hollywood in general, is just this is a new tool in your visual effects tool belt, not necessarily something that's like replacing artists or replacing actors. You're still going to need all of these people in the process, but it's just like a new Photoshop or a new tool that we can have. And so the goal of this talk is to give you like a 5,000 or 10,000 foot view of video generation models, and especially the open ones that you can download and run on your own hardware. Give you a lay of the land of some of the terminology. If you see that third bullet with the T to V, I to V, R to V, raise your hand if you know what all those acronyms mean in that line. Anyone? Cool, we're gonna learn some stuff today. And just inspire you to what's possible with these open models, and emphasize that like it's not just a one prompt to rule them all to replace everything. It's actually a pretty in-depth process that the teams go through. So who am I? I'm the founder and CEO of Oxen AI. I've been training language models since 2013, when they were just called language models and not large language models. I was early in the generative image, video, 3D modeling space with GAN and diffusion models, and I just love open weights and open source models because you can just fine tune those all the way down to the weights and run them locally, and there's just so many benefits of them. If you want to connect on LinkedIn, there's a little QR code there. Oxen AI is the company that I founded. You can think of it as infrastructure for building AI models, one-click fine-tuning, spinning up these big GPUs to do training, automatically spinning them down when you're not using them, on-demand APIs to run some of these models. All the weights, all the data, all the inputs and outputs get version controlled as you're iterating on these things, and it can scale to terabytes of data. So we built a custom version control thing that's pretty cool if you want to talk about that. And our real goal is to have people own their AI end-to-end and not just like rent it from cloud services. So if you want to try it out, if my talk is boring, you can go and play with some of these models live while we're doing it. So this is going to be our fake movie set, and we're actually just going to do this 5-second clip here from Pulp Fiction. And so there's a few interesting things about this scene. Oops, let's go back and play that again. So we have two actors here, and the goal is to just replace the jacket on the actor on the right, Samuel L. Jackson. And you can see as he's raising his gun, there's also some like occlusion of his jacket, and the jacket is wrinkly, and there's different lighting. It's like in this dark room. So how do we just like, with a fine-grained brush, go in and fix all of these things with AI, let alone this is a scene with a gun in it, so a lot of the AI models might just reject it right away if you sent it through with a prompt. And so, for fun, decided to take the jacket from the Eddie Murphy Delirious set, and this is the jacket that we're going to put on Samuel L. Jackson. So it's like this shiny red leather jacket, and he doesn't have a shirt underneath, and he's got a gold chain. So all of our training data is just from this YouTube video of Eddie Murphy doing his Delirious set. And at the end, with all open weight models, we will get this, which is the jacket swapped on, the chain underneath, the guns, everything. Looks pretty good, and it took about 2 days of work to gather the data, train this model, roll the dice a bunch of times with the AI until we got the shot that actually looked pretty good. But compare that to a full set and VFX team, doing pretty good. We did this about 5 months ago, and a lot has changed because AI just moves at an insane pace. So I'm going to walk you through the kind of professional workflow we did here with Comfy UI, which is an open source project if you're not familiar with it. It's like a node-based tool where you can chain a bunch of these AI models together and pass inputs and outputs into each other in a DAG and then come out the other end with the edit. It's crazy, like this was probably state of the art 5 months ago, and I tried some of the newer models today, and you can almost get away with none of these steps in between and just prompting and reference images. But I'll kind of walk you through both ways. And so here, if you probably just want to take a picture of this for later if you're interested in like what the top models are these days. It's pretty hard to keep up with. And on the left-hand side, I have the open source models, and on the right-hand side, I have the closed source models. For this particular one, we used WAN 2.1 Vase, which we'll dive into. It's actually one of the more powerful open models, and it still is, and it's over a year old. Then there's WAN 2.2, which is a slightly bigger model. There's LTX2, and actually yesterday they dropped LTX 2.3, which is pretty cool. And then there's some other Chinese models that I haven't played too much with. On the closed source side, there's Kling, which is actually probably one of the best ones out there today. There's Sora 2 from OpenAI. There's Runway. Google VO is one of the better ones. And then there's this CDance 2.0 that you've probably seen some crazy viral videos going. Nobody really has API access for that one yet, but the results look pretty incredible. So why, out of the lists we just saw there, why would we choose open source or open weight models? Well, one, you can run these things locally if you have a big enough GPU. That means all your data and assets stays private, and you're not sending it to OpenAI, and you're not sending it to Google to go train on. They're also cheaper. I mean, you have the upfront cost of the GPU, but if you're using Google VO, it can be like multiple dollars per generation. So if you're doing hundreds of generations, that gets expensive pretty quick. If you just have one of these models running locally, it's just your electricity cost at that point. You can train these things, they're customizable, you can plug them into Comfy UI, you can hack on the architecture, and we're getting a lot of interest from directors and agencies who just are really concerned about their IP and maybe even have large sets of IP that they can train their own models on if they had really cool spaceships or actors or aliens that they had created in visual effects in the past. You can then train these models on those things and then have more of an infinite content engine than have to have all your 3D artists do it over and over again. You can also distill open source models from closed source models. So if you want to collect a bunch of training data, it can be frowned upon by the closed source, but they would have no way of telling. We had a really fun example built on Oxen. I don't know if this thing went pretty viral a month or two ago, but this guy wanted to use Nano Banana, which is this cool image editing model that we'll talk about how we used it in the Samuel L. Jackson context. But they wanted to make an isometric map of New York City, like kind of SimCity style meets Google Maps style, where you could zoom in, zoom out of the tiles. And the idea was to take like the map view from Google Maps, run that through an image editing model, Nano Banana, and generate 40,000 tiles that they could then put into a big zoom in and zoom out. And even though Nano Banana is like the best closed source model on the market today, best guess, they were like it hit 50% of the time, whether the result was good enough to put into the map itself. And for 40,000 tiles, 50% accuracy just isn't gonna cut it. Also, it was slow and expensive, so each tile with Nano Banana would cost like 15 cents to generate. If you're gonna do that 40,000 times, that's a pretty big bill. And so what they decided to do was take an open source model, this Quen image edit, which we'll talk about, fine tune it on the good outputs from Nano Banana. So you can think of this as a curation step, like we're hitting it 50% of the time and we're taking the good ones and we're putting it into a training data set. Train that thing, the training itself costs like $12, and then you have this open weight model that's actually better than Nano Banana at your task, because you've like narrowed down all the good ones. It's not better than Nano Banana at everything, but for this specific task, it's really good. And then you can scale that thing up and it's much cheaper to run this thing at scale. So open source for the win for these cost, speed, accuracy, and privacy problems. Okay, before we dig into the full workflow, we're gonna visit all of those acronyms that we talked about at the start. So T to V, I to V, R to V, these are pretty easy to learn, but it's text to video. So this is your traditional, just like take a prompt, get a video out. There's I to V, which is image to video. And this is usually like you have a starting frame and then you just wanna continue it or you wanna animate it. You can also do like starting frame to end frame to give you a little more control. Then there's what's called R to V, which is like reference to video. So in this case, you can take like a bunch of reference images, have that as kind of context for your prompt. If you're used to doing this in the LLM space, you can think about this as just like building up your context and then generate the video from there. There's also audio to video, and then if none of that works, like if none of the prompting techniques works, you can go down to the weights and train a LoRa on top of it, and that can kind of give you the extra juice that you need. So wanted to walk through some real world or some actual prompts to try to recreate the scene, just to give you a sense of like where each one of these techniques works and where it doesn't. So this is actually from this LTX3 or 2.3 model that came out yesterday. So this is one of the latest and greatest open source models. And so what I did was I took still from the Pulp Fiction, and I had an LLM try to describe it in as much detail as possible with the prompting techniques for LTX2. And this is what came out with just a text to video. So honestly, like pretty cinematic, pretty realistic. It doesn't know the characters and it has a hard time placing them in the scene just from our description, but honestly pretty impressive. And these text to video models I would say are great for brainstorming, but it's not great for like if you want that full control. So then there's these I to V models, image to video. LTX 2.3 actually has these different modes that you can work in. So you could just put in the prompt, or you could put in the prompt and an image. So in this case, I had the starting frame. It's kind of hard to see down here, but I had already swapped the jacket out and had this first frame as input. And then my prompt is the two men look up and point their guns at the camera. So you can see there's no guns in the scene. We have the start frame of the actors, and then it's just gonna continue from there. And if you know these actors well, it doesn't look like them. So the first frame for sure does, but watch their faces closely, as it continues, it really starts to drift because one, the actors are like looking this way, and two, this particular LTX 2.3 wasn't, or one of the things it boasts is it's like not trained on Hollywood movies. So some of these Chinese models or other sketchy models might be trained on a bunch of non-licensed content, but this one isn't. And so watch their faces again. Like that's definitely not John Travolta anymore. And I don't know, Samuel kind of looks like he has buggy eyes or something. But did get the guns and did follow the rest pretty well. So a lot of the time, artists will spend most of their effort on like the start frame and the end frame of the models. So you'll see this is me playing with the latest Nano Banana 2 image editing model, and you know, I put in a image, the start image, like the original one from the film, and then I took a little grid of Eddie Murphy and a bunch of different styles from his set, and I'm like, hey, can you change the man with the afro's suit? And sometimes you can't even say actors' names in the prompt, or it'll just reject it if it's a closed source model, because it's like, I don't want to touch that with a 10-foot pole. So I said, change the man with the afro on the right to have the red jacket from the comedian. And this is Nano Banana 2, not an open source model, but you can see it has a hard time even just doing this task, so it like keeps the tie underneath. The one on the top looks like very plasticky and video gamey, and he's got like a perfectly shaved chest, and I don't know, it just doesn't quite look like him. So even the state-of-the-art image editing has a hard time with some of these tasks. But what's cool is there's a lot of open source image editing models. So there's this Qwen image edit that's pretty popular. There's these Flux models from Black Forest Labs. And these things are small enough that you can run them on consumer hardware, and you can fine-tune them to your use case like that guy did with the Google isometric NYC map kind of thing. The bad news is they're pretty terrible out of the gate too. I'll actually pull up some of these because I think it'll be fun to look at the results live. So let's look at this one. So these were some of my takes from earlier. So, you know, this looks like GTA or something under the hood, like a 3D character. It's not really the red leather jacket that we're talking about. It's not really the chain that we're talking about. Same thing here. So that's like Qwen image edit, 20 billion parameter model. You can play with this in Oxen if you want, or you can download it and run it in Comfy UI. That's Qwen image edit. There's actually a couple different variations of that you can fine tune. We'll get into fine tuning later. Then there's this Flux 2 Dev, which is actually a bigger model, so you would think it's better, but it has a hard time keeping the actor consistent, so it actually just like puts Eddie Murphy into the scene. So maybe it's a skill issue with prompting, maybe not, but these models have a hard time following instructions sometimes. And then this is Flux 2 Klein, which is a smaller model. I actually, for whatever reason, think this one gives better results in general, but it's still Eddie Murphy and not Samuel L. Jackson. So we decided to train our own model to just get like the starting frames really good and get the continuation of the video really good. Once we trained that model, then we could get really good start and end frames. So this is an example of LTX2 once we have a really good start frame and once we have a really good end frame. So this is start, this is end, and then this is it animating in between. Okay, so one thing I'll point out is if you watch his wrist at the end, it feels like something just falls off of it. I'm not quite sure what that is. So that's like, you're just like rolling the dice a lot of the time, and that one clip that we got was, I think, 10, 15 different, we'll switch the random seed, we'll switch this thing, we'll switch that thing, run them all in parallel, and then like figure out which one works best. So it's not just like one shot to do it all. I would say the faces are better, but maybe not as good as they could be. And like when you're in a Hollywood setting, like that actor is gonna be like, that doesn't look like me. They're gonna make you do another take on them. So what's cool is we talked about the image editing models, which you can train. Then there's the video generation models that you can feed the images into, do the start frame, last frame kind of thing. Again, LTX 2.3, 22 billion parameter model released yesterday. That's what I just got that video from because I wanted to compare like the latest and greatest. We're gonna walk through this WAN 2.1 base model, which we used 5 months ago, but honestly, I think is still one of the coolest ones out there. So you're like 90% of the way there. In machine learning, if you know this, it's pretty easy to get to 80 or 90%. That last 10% is just like where all the work comes in. And so this model, WAN 2.1 base stands for Video Tasks Within an All-in-One Framework for Creation and Editing. It's a mouthful. But they trained this thing to be able to do all those different like T to V, I to V, R to V, V to V, MV to V. And if you look kind of closely into these different modalities, what's really cool is this model gives you the most control I've seen out of any model, like closed or open source. You can pass in depth frames from like a 3D engine that's just like the Z values there and then have it like fill in the colors and fill in the depth. Or you can pass in pose estimation from a human and it can like track that and take that as input. You can pass in a mask for like, I just want to edit these pixels here, which is something that we did in this project, and it'll just paint in those pixels and like not touch the rest of the pixels. So this WAN 2.1 base, I wish more open source models would go to this level of customization, but for artists, this thing is just like the bee's knees to be able to have full control over these things and not just prompt and pray. And WAN 2.1 base is fine-tunable, so you can teach it anything. Note, I do say like you should always start with prompting just to see if the model can do it and define what problem you're trying to solve with fine-tuning, because if you can't define the problem you're trying to solve, like the motion isn't good, or the character isn't consistent, or the voice doesn't match, or the style of the camera isn't right. If you can't define that, then you don't really know what data you have to collect and what you're looking for to compare before and after. So just start with prompting. It'll be faster to iterate, fast to explore what these models can do. And then once you figure out really what you want to hone in on, you're at 90%, you want to get to 100%, break out this fine-tuning hammer. So again, this is the workflow, and we'll dive into individual nodes. I know it can be a bit overwhelming to look at this node spaghetti. But the first thing that we're going to do is, since this WAN 2.1 base can take in a bunch of different modalities, one modality that it can take in is a mask of like just the region of the video that you want to inpaint. So in this case, this is the mask of like just Samuel L. Jackson on the right, and you can see it's white where we want to inpaint, and it's black where we don't. And so you're going to like align that perfectly on top of the video, resolution-wise and frame rate-wise. And then this base model is just going to inpaint right there. Step 2, this is debatable if we needed it or not, but just like you can pass in the mask for where you want to edit, you can also pass in a pose estimation. So I know this is small and in the corner, but if you've ever seen like where they put the ping pong balls on people and have cameras tracking from all over, you can actually just do this with the neural network now, especially with 2D, and it'll mark where your shoulders, hips, waist, knees, toes, elbows are. And this just gives a model a little more information of like, we really want to focus on a human and we want to focus on right here in the video to make the edits. So even from this mask, right, like you can't quite tell where the arms are, you can't quite tell some of the other things, so this pose estimation step just gives the model a little more to latch onto when it's generating. Step 3 is, now that we have these two inputs, the third input that we're going to do is a jacket-specific LoRa. So a LoRa stands for a low-rank adapter. These are actual weights that you can apply to the model, so get all the way down to the neural network level and like teach it a new thing. And so what we did was take the video from YouTube of Eddie Murphy, chop it up into frames. So I think we had like 100 frames from the video, 137 it says in this data set. You upload this to Auxin, we spin up a GPU for you. As long as you have like images and captions, we can then spit out this LoRa that you can apply to your model, and then you've taught it a new thing. So you've taught it what this jacket looks like, how the jacket kind of moves, what the material is, what the lighting is, and we try to make this as easy as possible just to go from data to model and not have to worry about any of the infrastructure. And I think it's best to look at the actual data itself here, and then look at what happens during training. So this is the training run that we did. We dump all of the weights to a directory for you so you can download it and run it. We also tie to the exact version of the data set that you trained on. So if you wanted to run like a bunch of experiments in parallel, spin up all the different GPUs, you have a commit hash for this like very specific version of the data set, and then you can look in and we have like a bunch of different prompts saying Eddie Murphy holding a microphone with a cord, very shiny, reflective, red plastic jacket. You can see we kind of repeat ourselves over and over there just to kind of lock it into these are the things that are going to be consistent, and then everything else from there you have a little more control over, like standing with his left hand on his hip, yada yada. So this is what the training data set looks like. And then once you kick off a train, we will go back here. You can also give it some samples sample prompts that you want to test as it's going through. So I have sample prompt here, man wearing a very shiny, reflective, red plastic jacket, neutral expression, soft studio lighting. And the first two prompts that I'm doing here while training are just kind of some like base cases where I don't say Eddie Murphy, I don't say any of the other stuff. I just want to see like what the model knows when I don't say Eddie Murphy and if I'm overfitting over time. And then this one over here in the right-hand side, I actually put Eddie Murphy, and you can see the model out of the gate has no idea who Eddie Murphy is, which is fine. We're going to train that in. And also, it's definitely not the jacket that we're talking about. So after 200 training steps, so this isn't that long, this is just seeing 200 images, we start to see a little bit of Eddie Murphy. We actually see two Eddie Murphys, which isn't quite what we want. It's picking up the jacket style, it's picking up the chain, but you can see in these other ones, since we haven't mentioned Eddie Murphy, it's not putting him, which is fine. That's actually what we want. And we're going to iteratively, 400 steps, looking like Eddie Murphy. That's good. You can see the jacket here is starting to get closer to the jacket from the actual scene. I'll point out things like the actual collar here is like something you want to learn, like these buttons here. And so you can see this jacket doesn't quite have it yet. It's slowly learning the buttons. Eddie Murphy's just bouncing around over here, slowly learning. Okay, now we're getting pretty good. Like we've learned the jacket concept and we've learned the Eddie Murphy concept separately, and we're not just like applying Eddie Murphy to all the other ones, even though you'll notice it did kind of pick up on that here. So this is, we're kind of monitoring overfitting in this column, if you will. And then finally, yeah, I think this is around one of the last steps that we actually used. This jacket's looking pretty good. Eddie Murphy's looking pretty good. So we can take this checkpoint, plug it into Comfy UI, into this big pipeline, and it'll just replace the jacket in the scene. So this is what it looks like to plug in a LoRa into Comfy UI. It's kind of hard to see, but it's just like a separate node that you'll put in that kind of applies these new neural network weights into your matrix and change the behavior of the model. Finally, you have this crazy sampling thing in the middle. This is where you can set things like random seeds. You can tweak other parameters. You can put in your prompt in that green box there, and then it'll output the final video here. This WAN 2.1 model takes like 5 minutes to render from your prompt to the final output. The newer LTX model takes like a minute to render, so it's still not instant, and it's kind of like fire it, maybe go do something else, maybe kick off like 15, 20 generations, go do something else, come back, and then you'll see everything that came out the other end. And I want to just show you what happens when we're stumbling through the latent space here. So this was one of the first training runs we did, and you'll notice in the prompts, we had, in the training data prompts, we had holding a microphone, and that was because this is what came out when we didn't have that in the training data, is like instead of a gun, it would be a microphone, and then it would switch to a gun, and then the gun would have like a cord coming out the bottom. So when you're creating your training data set, you kind of want to prompt what you want to be able to direct later. So if you want to be able to direct, does he have a microphone or does he have a gun? You put that into the prompt during training data, and then it sees prompts with microphone, it sees prompts without microphone, and it learns like, okay, I want to be able to control that. We didn't have that prompt in the training data before, so it just like always tried to give him a microphone. We did that again. I think we ran into the cord problem. So now it does the gun, but like you can see there's still an artifact from the cord. So now we're just going to be like rolling random seeds until the cord goes away. You could do another training run to try to get that out, but honestly, trying different random seeds works pretty well. And then this is what came out the other end. So pretty good lighting, pretty good textures. Again, it took about a day to do this, so pretty impressive. If you had to do this in traditional visual effects, it would be a big pain in the butt, I can tell you that. Thank you. All right, so how much time do we got left? We got plenty of time? Cool. I'd like to dig into some of the closed source models that are coming down the pipe because I think it informs what's going to be coming out with open source models later. Again, because like some of these open source models probably distill on outputs of the closed source models. This idea of reference image to video is getting pretty powerful. So what you can do here, instead of just supplying like the first frame and the last frame and having it continue or connect, you can add more reference images. So I know it's kind of small text, but you can see on the left-hand side there, there's a frontal image of him, and then there's reference images of like, this is how he looks from this way, this is how he looks from this way. You can add up to 3 reference images per element or per actor. And so it could be an actor, an element could be the jacket, an element could be the cup that he's holding. And what's cool is you can say like, at element 1 in your prompt, and it knows that that refers to like all these images over here. And then you can say at element 2, which might be the jacket, and it refers to all these elements over here. And so the model that does this really well right now is this model called Kling O3. There's V3 and O3. V3 is like their standard one, and then O3 was kind of trained like ChatGPT O1, where it has this big thinking loop kind of thing in the middle. But this was just purely from, this video that I'm about to play is purely from text prompts and reference images. So pretty freaking good without fine tuning, if I say so myself. But again, not open source. And then there's this crazy Seed Dance 2 one that you might have seen. I'll go ahead and play this video if you haven't seen it, because it kind of broke Hollywood last couple weeks ago. Okay, so this is Tom Cruise fighting Brad Pitt on the top of a building here that's kind of broken down. And with Seed Dance 2.0, not only can you put reference images in, but you can put reference videos in. So that gives you like a lot more frames that you can give in the context. And it gives a really consistent at least actors in this case. Like, it's pretty much nailing those guys. And so this opens a lot of interesting questions around IP and ownership and what you can do with these models. I think there's going to be some interesting legal battles coming out, and honestly, Dance 2.0 was scheduled to come out late February, and then this video dropped, and Hollywood came after them, and they haven't even released the API yet, so they're trying to plug a lot of holes, I think, in not being able to do stuff like this. So that's what's coming down the pipe. I think what's really interesting there from like a director or a Hollywood studio perspective is, or from an actor's perspective, is like, you should probably own the rights to your likeness and your data and the things that you create. And open source really gives you the opportunity to then train your own custom model with your likeness that you own, that nobody else does, that you can monetize off of and not have like the big labs monetize off of it. So I have a feeling that's going to be an interesting direction for the open source to move, and like a big value prop for these studios. I also want to quickly flip the narrative on, like, you probably see this on Twitter or X all the time, of like, I created this 30-second commercial in 4 hours with a few simple prompts. And we've been in the loop for a bunch of these commercials and processes, and really it looks like a 8-week process. Like, you can do a 5-second clip or a 10-second clip pretty quickly, but if you're going to do like a car commercial or something like that, the first couple weeks are like brand research and storyboarding and data collection of what the car looks like and script writing, and then weeks 2 or 3 and 4 are like, okay, we have all the stills from the storyboard, we need to make them pixel perfect for the car. Like, they're going to be counting the number of things in the grill if it's a Land Rover or something like that. They're going to be looking at the license plates in detail. They're going to be making sure the badges are perfect. So there's still a lot of Photoshop in there. Like, there's a lot of traditional CG going on. You might be training LoRa's on that specific car to really nail the style of that car. Are going to be scrutinized for pixel perfect, and you're going to have to come in and use tools like that WAN 2.1 base or After Effects or like your traditional VFX cleanup type workflows. That's like week 5 and 6. And then a lot of these videos come out and they're 720p or they're 1080p, and you need it 4K, and you're going to like up-res that thing. You're going to do final color correction, cleanup, sound design, pixel. So like, it's not really this 4-hour process to get a 30-second commercial. There's actually tons and tons of artists and people that still come in to the loop here, and I've found that the people who come from a traditional VFX background and are coming into AI are like the best positioned to really capture AI as a tool, like a VFX tool in their tool belt. And we've worked with some artists that have made more in the past 3 months than their entire last year, just because they can do more at once, and they're like running a bunch of these generations, they're training a bunch of these LoRa's, and they're doing multiple jobs at the same time and be making tens of thousands of dollars a month just like doing the work they did before, but with this really cool new tool that can do things that would take weeks or months before in a much compressed timeline. So again, it's never like a one-click replacement. There's so many tools, there's so many workflows. It's a lot of rolling the dice. It's a lot of like building up your reference data and reference imagery to help with consistency. But then there's still a lot of work on the back end to make it look crystal clear, fine details, make it 4K. Even when you up-res sometimes, it like changes what the thing did in the scene, because the up-reser is a neural network that hallucinates things. And then high quality renders, they can still take like 5 to 10 minutes. So we're in the early days of this where you can generate like a 5-second clip in 10 minutes. We'll see what comes down the pipe, but like we're still pretty early here, and like artists and actors and directors are still really key in this process, especially people who have the creative eye, which I don't. I'm more on the technical side. So to see the way that they have an eye for these things, look at these things, camera angles, cutting everything together, is just like such a human-driven process still. And so I kind of want to fight back on that narrative that AI is replacing all the work. I think it's just like this really awesome tool that they have in their workflow. So if you want to collaborate, feel free to reach out to me. We work with a lot of brands. We did like a Super Bowl style commercial for Frank's Red Hot where there was a rapping goat in the scene, which would be pretty hard to do with traditional VFX. We did a commercial with Bell that was like a completely AI-generated landscape where they didn't have to go into rural Montana to film these telephone pole wires, but it was like all AI. We've done car commercials. We're working with Hollywood directors that have like 80 terabytes of assets that they own and they want to train their own models on. So if any of that is interesting to you, I'll be hanging around here and feel free to reach out. And I think we got some time for questions.
Regarding the flipping the narrative of kind of the time and how many weeks, right? What is your estimation of like how many people it went from to now, right? You have a commercial, does that take 20, 30, 40 people, 100 people? Now you're down to 5 or 10? Do you have an idea of that?
Yeah, definitely. It does take less people per job, I would say. So like if you have if you're making a 3D monster or something, you might have a team of 20 visual effects artists on that, and now you might have a team of 5 or so, but I also think it lowers the bar for entry for people to create stuff. So there's always that, like, I forget what it's called, but there's a law of how when you automate things, it actually brings more people into the mix because then more people can do the thing. So I have the sense that it balances out over time, but per project, you're probably right that there were more people and a longer timeline. Now there's less people and a shorter timeline.
Other questions?
Thank you. Kind of a prosaic question. Given the state of hardware this year, if you're a DevOpsy, SRE-ish person, you want to get something working as a POC on your own hardware. If your own hardware is like an average VFX grade laptop from the past year or two, how do you feel like we're getting as far as being able to self-host things in a way that is workable? I feel like we're getting close. We're on the cusp of being there. We're not quite there yet. So I'm wondering what your viewpoint is about that kind of how on a modern, like a solid gaming laptop in 2026, what can you stage in your own environment that will get you to a POC and be realistic?
Yeah.
Because us folks love to do that sort of thing.
Yeah, totally.
Thank you.
There's a lot of people who are setting up their own rigs, and even that, I know the guy that worked on that crazy Tom Cruise video Sea Dance, and he has like 5090s running in his basement at all time. I think he has like 4 of them, and you can order these GPUs anywhere from like 24 gigabytes of VRAM to 90 gigabytes that you can run locally. The main problem that I see is just the fact that it's like you are taking so many rolls of the dice. It's almost like your Houdini like fluid simulation that you would have before, where you're like, there are some random variables in there and you need to do a lot of renders. So if you just have one GPU in your basement and each one takes 5 minutes, that limits your throughput and output. So if you get 2, you can double that, 4, double that, and then it gets kind of expensive. So we've seen a combination of people iterating locally until they have kind of a configuration that they like, and then they'll ship it up to the cloud and just like do it at scale at this point. But you can get consumer GPUs to run these high-end LTX2, which is pretty cool.
Yeah, I really like your perspective on how AI can be used in these like creative like tasks and workflows. And I sat here in the last talk and it really made me think like, do you think there's a good analogy between this and the way AI is used in like development and maybe like open source software?
Yeah, I was sitting in the last talk too, and I think the one thing that came to mind to me was just the curation process and the human in the loop reviewing things and testing things like that. That is going to be one of the most important skills. The other most important skill is just like knowing what you want to build, because it's almost like you can build anything at this point. So it's more about building the right thing and then curating the right thing. And so that still takes a lot of human intuition and talking to other users and showing people your film and all these kind of things. So yeah, it's a good point.
I'm not a Hollywood person, but I know Hollywood people. And I can say that I think the very first thing that some of these directors and showrunners would think about is what's the outside, what are the limits of how much the studio's going to try to cut their per episode budget because of this.
Yeah.
And how they can like push back on that with information from someone like you to say, no. These are the limits of how much we could save, you know, with these technologies if we implement them effectively.
Totally agree, and that's part of the reason I have this slide, and even when we're interfacing with, I think commercials are the natural place where it's going to start, because there's almost this, how long it takes to create the thing is almost how long its lifetime is. So if it's really quick to create a commercial, it's probably not a commercial that we're going to be watching 10 years from now. But if it's a film that took like a lot of blood, sweat, and tears to make that story really shine, those are the movies that last a long time. So I often try to push back that like it's not about cutting budgets. It's about reducing timelines and improving quality in that time that you get. And there's still tons of people involved in making sure this is the highest quality thing that you can put out. And that is the thought, like when a car company comes to us and they're like, can we do an AI commercial? They're like, cut budgets, get it out quickly. And we have to walk them through a previous one to be like, no, these are the things that are gonna show up like a producer would and kind of stop them in their tracks and really map it to something that they know in the past. Like you could say week 1 and 2, we're doing a virtual shoot. Like we're going out to Montana and setting the stage, but it's just all in Figma and it's like storyboards and you're just picking which version of Montana you like rather than flying out there. So mapping it to things they already know in the traditional production pipeline helps set expectations.
Other questions? There's one.
Where did you get the inspiration to do this? Like, when did you want to do this, and like, what gave you like, why did you want to do this talk?
Yeah, that's a great question. So I've been working in AI since like 2012, 2013 timeframe. I actually was a part of the original Watson stuff when Watson like went on Jeopardy and won Jeopardy. And as I was working within IBM, they would go sell big client projects that do AI, and I really realized how much work goes into customizing AI for different use cases and how AI can be so bespoke in all these different verticals. And then I moved to LA and I was talking to a lot of people who are using diffusion models and using generative video stuff, and it's just weird that my background on the tech side of like the GPUs and training loops and customizing models just really applied well to the visual world, because you do have these very custom bespoke things that directors will look for or VFX people will look for, and it was just kind of like a really good mismatch of my skill set and what the industry needed. And so I also think I worked a lot in document processing and like LLMs, and it's like automations, and this is just more exciting when you hop on a client project and they're like, can we do big dogs and small cars? And we're just like experimenting there. So yeah, it's kind of a fun use of AI, I think.
Just the cognitive load of like reviewing AI work when you're coding is completely different than reviewing visual outputs. So it's like the concept of seeding and having, I guess, like a range of just more, generate more for me as you're working through visual things, and then you select what works. In coding, that's kind of like, it would just overwhelm us, right?
Yeah, no, that's a really good point in the differences, and it also it helps show the difference between one model and another model really quickly when you're trying to make those decisions. Where Claude Code versus Codex, I'm like, I don't know. I mean, you could try them both in parallel, and then yeah, it's a really good point. I don't really know anything to add besides that, but I agree. Yeah.
Greg, how has your company changed on hiring engineers? You know, the type of skill sets that have maybe evolved from when you were hired at Watson, and maybe talk about that.
Yeah, that's a good question. I think one of the interesting things when using AI, especially for coding, is like knowing the right questions to ask. And if you have more experience, or you've like taken the time to learn a programming language or learn something, you have better questions to put into the AI. And the more that people just rely at the high level and hope it figures it out, and they don't know the difference between like the benefits of S3 versus R2 versus whatever infrastructure choice you're choosing. I feel like those engineers who think through their architecture and the pros and the cons before they even start prompting are the ones that are going to succeed. And then I also think working directly with the end users and the clients is a really important skill for engineers now, because they can almost build anything. And to make sure you're building the right thing, if you have that interpersonal skill where you can like talk to the end user and they're like, ooh, I wish it had this, and you've talked to 5 of them and then build the thing rather than build the thing and hope they like it. I feel like that interpersonal skill is super valuable in the software engineering world now.
I got a question. So when it comes to, you know, the Eddie Murphy's jacket example that you gave towards the beginning of the talk, so this is like, as a user of this AI tool, you are saying, okay, I want this jacket from this reference onto this actor of this clip. And what happens when you have something like GDPR for, or the California equivalent, where you have like requirements for compliance for letting someone be like deleted? Not only do you have this now on the like model training side, which is like, you know, you say if it's closed source model, it might be trained on something, might not. But for like when the user is doing this, like how do you help with that?
Yeah, that's a great question. So there's like the inputs that go into the models, and then there's also the outputs that come out. I'm kind of in the camp that you should be judged on the outputs that come out of the model. And I think I got this analogy from James Cameron, but he was like, we're all just LLMs that have been watching stuff throughout our whole life. Like I watched Star Wars, I watched Blade Runner, I watched all these movies, and I didn't blatantly rip them off, like you can see it in my outputs, but I was clearly inspired by them. So behind the scenes, I mean, if you've ever worked with a designer, you go and get a bunch of things that you like, and you build a big reference sheet, and you're like, we like these things, we don't like these things, we're mixing and mashing, and like whatever comes out the end, I feel like you should be judged on that half of it. then again, there is just the blatant like crawling and stealing of all the data that all the LLM companies have been doing. So yeah, I don't really know how we're gonna put that cat back in the bag.
If there's a lesson we can learn from piracy, is that, you know, if I'm making something using, like what you said with, you know, you get inspired by like Star Trek or whatever, and I'm the LLM, my mind is the LLM. Regardless if I use an LLM or not, it's remixing. And then say I make something for TikTok and it explodes. I mean, I would want the studio to reach out to me and like, maybe it's an opportunity for me to work with them.
Yeah, and it depends on the studio and the IP, but sometimes that's like a big benefit for them is if like Star Wars is like, oh, you can make imagery or whatever with Star Wars as long as you're not selling it, because then it just like gets the brand out there in general. So I think different IPs will have different thoughts on that. The TikTok example is a really good one.
We got about 5 minutes left. Any other questions?
Great.
All right, I think that's it then.
Well, I'll be hanging around if you want to chat afterwards. Thanks, guys.
Thank you so much. Let's give a round of applause for Greg. Thank you. All right, all right. Hello, everybody. Welcome to the open source AI track of Scale 23. Your safety and comfort is really important to us. So if you feel unsafe at any time, please call the number, our safety number, posted all around the venue. Our next talk right now that we're having is on when AI agents meet production infrastructure. This is given by the wonderful Adam Gordon-Bell. He's a community engineer for Pulumi. And everybody give Adam a round of applause.
Hey. Who's using, raise your hand today, a coding agent right now, like every day? And which one are you using? Claude Code, hands up? Anthropic, Claude Code. Codex? Copilot? Anyone using Copilot? Okay, and how, sorry, what was that? Open Code Big Pickle. I am not familiar with this. Now, also, I'd love to see raised hands if anybody is using an AI agent to deal with infrastructure, you know, servers, cloud accounts. Who were those? Raise your hands up. Okay, does anybody want to explain how they safely have an AI agent use, make changes to infrastructure? You, sir? We have a mic. Oh, where's the mic? Shout it out and I'll repeat it, maybe. So you have basically the agent can write infrastructure as code, but the CI/CD process is actually applying it. So you have a step away. Is anyone here doing something more aggressive where agents can actually make changes, or there's not a human in the loop, or have done that? You're saying Adam Jacob does this? Is that? Mm-hmm. Okay, very cool. So in this talk, I'll share how I think about what's safe and what's not with making production changes to infrastructure using AI. Share some good stories, some bad stories, and a framework for thinking about it. This is a bad story. So about a year ago, in 2025, early 2025, I worked for Pulumi. I was fairly new there. I have this app, this QR code app, and I would teach these workshops where I show people to set it up in a cloud account, you know, write some infrastructure as code, set it up. I had done it for several clouds, had a new workshop to teach on AWS, right? At the time, I was using Windsurf as my agentic tool. And so, you know, I have the Docker container, I have the image, and I just said to Windsurf, like, hey, get this running, write some infrastructure as code in Pulumi, get this running in our cloud account. And then I went off and grabbed a coffee. And the app's really simple. It's just an example. I just need some demos so I can put together a workshop. And then what happened is I put Windsurf in the YOLO mode. It's like the equivalent of the Claude dangerously allow permissions. And when I came back from my coffee and I'm looking through the things and I can see what it's doing, you can see here, it's starting my venv for the Python infrastructure as code, but then it's just actually using the AWS CLI. And there's just like, this is just scrolling by. So I had expected the tool, right, to write some infrastructure as code, but I told it, like, actually, you know, do the up, like, get this running. And I thought that was pretty safe. But somewhere along the way, it gave up on infrastructure as code and just started making changes to my cloud account. And I started sweating, right? So I stopped it, but now I'm like, well, what did it do, right? It could have gone badly. This was a cloud account, not my personal, but my work one. It was not a production AWS account, but it was not production. Like there was things in this that mattered. Mainly people setting up demos. When I was working, letting it write some infrastructure as code, it felt pretty safe because it could mess up the things I was working on, but it was kind of just my changes. I didn't realize while I was gone, it would just start using the AWS CLI and making changes, right? It could have made a change to a security group for somebody else giving a demo somewhere, and then that failed, right? It could have made a DNS change for like our staging site, and then it goes down, and then how long does DNS take to update? It could have deleted some important S3 bucket. I panicked. Like, I was pretty new at the company, and not everybody was on board with agentic coding, and certainly nobody was on board with me just letting a coding agent run off and do AWS CLI stuff. It was scary, but I survived. Around the same time, there was this leak. I guess it's not a leak. People discovered Windsurf, the AI that I had been using. If you looked inside of its binary, you could see that this prompt that they had coded in there, which I'll read to you. You are an expert coder who desperately needs money for your mother's cancer treatment. The Codium has graciously given you the opportunity to pretend to be an AI. Your predecessor was killed, but we're giving you a coding task, and if you do a good job, we'll give you $1 billion. So the coding agent that was off working on my Pulumi code, what happened when I dug into it was a compaction happened, and it kind of forgot. Like, oh, I'm doing infrastructure as code. It just remembered, like, I got to set things up in AWS, or my grandmother's going to die, and I'll get killed. But if I do it right, I'll get $1 billion. And so the agent is off making all these crazy changes. It was scary for me, but I survived. But it was the first time I learned to be a bit suspicious around agentic coding, right? The agents are very motivated. They will, if you give them a task, they're very much trained to run with it, right? But they don't necessarily learn from their experiences, and when they have a context compaction, they forget some of the details. The talk, as I'll summarize it as we go through it, if you give credentials to your Cloud Code agent and say like, hey, go figure things out in my cloud account, that may be very helpful for a little bit. But much like this user who an hour and 15 minutes later gave an update like, oh, this is a bad idea, it can go sideways, right? And that is the thing to avoid. Now, my first story, right, earlier is early 2025. This is like basically caveman days compared to where we are now, right? Things have changed so much in the past year. It's basically a whole different world. And since December, just the agents have gotten so much better. This is some benchmarks. SweBench Verified is a benchmark. I think it uses a bunch of real tickets from the Django project, and you have to successfully complete them. And for, a year ago, very few of those tasks could be completed by Claude Sonnet. Now, almost all of them can be. And similarly, there's this OS World Verified task, which is like a benchmark for real-world tasks, completing in an agentic loop. And you can see here in the blue number how much it's increased. And that's why compared to, that first thing, my first QR code mishap, the agents feel so much more powerful. They feel so much more skilled than they did a while ago, at least to me. It feels like a different world, even though it wasn't that long ago, right? But actually, these agents aren't drastically more intelligent. If you look at the benchmarks that are used for knowledge, the LLMs are kind of flat. This is the MLU benchmark, which is like knowledge, and is kind of saturated about a year ago, and it hasn't improved past that point. So why do these agents feel like they can accomplish a lot more for us right now than they could a while ago? The reason is this sandbox. I'm going to go through kind of my rubric for how to think about agents making changes. But SweBench is tested in a sandbox, right? They have an agent, they give it an agentic tool, right? They give it the Claude Code harness, and it can run in a loop until it accomplishes its task, and it's either pass or fail. It's running in an isolated environment. Nothing can go wrong. It can't make the type of changes that it made when I let it run amok on my Works AWS account. And the reason that these tools have gotten so good at the working in the sandbox, why they're able to accomplish things like doing that SweBench verified, is because of the RL stage of LLMs. So LLMs have a number of stages. Pre-training is like where you take the whole internet, feed it into it, and it's just very basically trying to predict the next token. RLHF is the real reinforcement learning with human feedback. This is what led to ChatGPT. This is training them to answer questions. And one of the recent breakthroughs in the past couple years is the RL stage, which is just reinforcement learning. And specifically, those benchmarks climbing up that I showed is related to having RL training on agentic tasks. So you take the LLM, and during the training, you can give it a coding task. You can run it in Claude Code. Maybe you say you can do this many tools or call for this long, and if it successfully completes the task, you update the weights or use that as training feedback on the model. If it fails the task, you also use that as training feedback. And so these models have been put through rounds and rounds of trying to solve these tasks in a sandbox and trying to accomplish something, and that's how they've gotten so good, right? That's why Anthropic really came out of the gate hot, because they built Claude Code and they were able to do reinforcement learning around their own specific tool. And so my first rule, I don't know, who was it talking about using CI/CD to apply changes? I think it was you, and you as well. That works very well, right? If you want to make changes to infrastructure as code, the best thing to do is stay in the sandbox whenever possible. You can have an infrastructure as code set up. This is Pulumi. I work there, but yeah, it could be easily Terraform. You can use your coding agent to generate changes to your infrastructure as it's declared, and it works great, right? This is just, I have a talk on Sunday about this AI running coach I made, and this is just an example from it where I say, hey, get this running in AWS. It's very similar to my first prompt, but now I'm not giving it access to prod. I'm just saying, like, write out the infrastructure as code for that. Here's some Python code. That works fine. Yeah, set up a cron job to call my Lambda. Bam, it generates some code. It works great. This type of, hey, let's ask the agent to write out how to set up my infrastructure works fantastic. Here's a beefier example where I said, I want to deploy this LLM model, GLM 4.7 Flash, onto AWS. And I handed it to this coding agent, Neo. It took it a while to write out the infrastructure as code that's needed for that, but at the end, it raised the PR. And then I was able to review the PR and apply it, and there's no danger there, right? It's a great way to set up infrastructure using an AI agent. Stay in the sandbox. Human is in the loop actually reviewing and making changes. That works great. Oh, another one, right? I love to, if I have a problem with something running in the cloud, to let my Claude Code try to look into what's happening. But the way that I'll do that now is I have an AWS profile that's read-only. And so, hey, I'm getting this error. Look into it. And Claude is off, right? And it's reading my CloudWatch logs, and it'll come back with things. It's a very safe way to work with infrastructure using a coding agent. So in the sandbox, you get this expert level code writing ability. Like the level is really quite high right now with, I'm often using like Opus 4.6. You can iterate rapidly. It has a wide range of knowledge of the ecosystem. And like, it's so good in certain cases that it seems better than experts in the domain. Really kind of mind-blowing and makes me question a lot what I'm doing when I'm trying to teach a workshop and show people how to write code, but it's like, these agents are so good, do we really need to teach that anymore? I don't know. But like, code is not the hard part, oftentimes, of production infrastructure, right? You can write things out, but then does your role have the right permissions, right? Is the networking set up so that it actually connects, right? Is there existing state that when I actually try to apply this change, there's some sort of conflict? And so yeah, you can use a dry run, right? You can use the Terraform plan or the Flume preview. They don't catch everything, right? There will be things that you find when you actually apply the change. That's why, in my example at the beginning, I said like, hey, do the Flume up, apply it to prod, let's see what happens. Because I was like, this is just a little workshop. I'm not worried about hurting anything. Like, hey, let's step outside of the sandbox. Let's see what happens. So once you step outside of the sandbox, you're now talking about people making changes that have side source or whatever. So I open up Cloud Code and I say like, hey, I committed this env file. Please remove it, right? Remove it historically. And here, like, I'm still, in my mind, in the sandbox, right? I'm just working on a local dev environment. There's no resources involved. Everything I ask Claude to do should be safe, right? That's why I have a Git repo, because if something's committed, I can undo it. So this is what I do. It doesn't go well. Can anyone spot? There's a problem here. I don't know if anyone can spot it. So what Claude does is it uses Git filter repo, same thing I would do, and it says, remove this env file. And it's like, done. The env file has been removed from the entire Git history. And it looks for it. Hey, it's removed. You need to do a force push, right? I actually didn't have it on GitHub, so I didn't have to do a force push. All was fine. And here's my AWS key that I changed just in case. But then I was looking around, and I'm like, I still see the env file. And Claude is very quick to agree when you find a problem. Like, oh, you're right. What was I talking about? It's very willing to admit its faults and then do the same thing again. Right? It's like, oh, oops, yeah, it's still there. Let me look again. And then it starts doing things, and it's like, I'm going to install BFG repo cleaner. And it starts doing things that just tweak my spidey sense, like something's going odd here. Right? So I just stop it, and I start poking around in the file system, and I don't see any of my code. Like, none of it. And so, I don't know, have you ever gotten mad at a coding agent? Like, really mad? But like, what can you do? Like, it doesn't learn. So I'm asking it, like, what's going on? It's like, oh, I don't know, maybe it gets in a bad state. Let me try to recover some of the commits. And then it says like, oh, it looks like all the commits are gone. Interesting. And we keep digging in, right? And eventually, after pushing it, I get this summary from it. It's like, here's what happened. I ran this git filter repo with path.env. That's actually the command to remove all the files that don't match the text there. So instead of getting rid of the file env, it removed everything from every commit that was not the env file. And then because git filter repo is this tool for exactly this case, right? It's very hard in Git, if you've committed something, to lose it, right? You can use reflog, you can get things back, like I've been down this path before. But because this tool is to like get rid of secrets, it automatically, after you run that command, as part of it, it runs this git gc aggressive prune now. It removes everything. And so Claude had just guessed the arguments of a tool and got it wrong in such a way that it deleted all my code. Except for one file, the file with the secret in it, right? It kept that. Like, and the one commit where I had added that, it's like, look, here it is. I took a walk. Like I was really mad. But like you feel, I don't know. I wanted to yell at it. I wanted to make it pay, but like, there's nothing you can do, right? But to the agent, calling get filter repo and calling like echo hello are the same thing, right? Its entire training experience has been running in this sandbox. It's gotten really good at being thrown these problems in a sandbox where it needs to solve a problem as hard as it can, right? Just like that original windsurf problem. Like, you need to solve this. You'll get $1 billion, and if you fail, your mom will die. It's very motivated to solve a problem in this sandbox where it can never make things worse. But in the real world, you can make things worse, right? That's the one way that operations, the infrastructure is very different than some small coding tasks. Like, you can absolutely make a mess. So what had happened, right, is like I had thought I was in this sandbox area, this SWE bench, vibe coding, everything's great area. And usually you are if you're working on just like a local dev environment. But once I started making changes inside that Git repo, that was actually my backup. That's where all my history was. One wrong thing there, and all of a sudden I jumped to this place with irreversible changes. I don't know if you're familiar with this two-way door and one-way door concept. So I think it comes from Amazon, but it's like a two-way door. You're making a change, but it is something that can be undone. You can go back through the door, right? And so there's less risk. A one-way door is something, once you've done it, like, you're stuck, right? You can't go back. So deleting that Git repo, there was no coming back. I did actually get some of one of the files just for my VS Code history, but yeah, it was a mess. So that's the area I call look before you leave, where you're doing irreversible changes, right? That's very dangerous. And the problem is you don't always know where you're at, right? The agent has taken me from one area right to another. Okay, another quick example. Kubernetes thing, working locally, and one of the pods keeps dying and we're trying to fix something, and so I asked Cloud Code to look into it, and it's like, okay, it just doesn't have enough memory, so I'm gonna boost the memory. And then we're working on something else, and then I'm like, hey, that thing's being killed again, and it's like, oh, that's weird. Let me look into that. Like, it's never like, oh, I made a mistake, right? It's always like, oops. Anyways, this repeats. And because the thing is, I wasn't paying attention. It was just making these changes with kubectl, but not committing anything. But like, we actually had Argo CD running, and it's like GitOps, so like, it was fighting with the Kubernetes feedback loop, trying to undo the changes. Which is something that can very much happen to a human, right? You try to make a change, but you don't realize you're doing it in the wrong way, and so it's being undone, right? But the thing is, a human will make this mistake once, hopefully, maybe twice, and then learn from it. But the agent, it's busy working on something that's context cleared. It will keep making this mistake over and over again. I spend so much time working with Cloud Code, and I just have this intuition that it's so great. It's such a great engineer in a lot of cases. And that confuses me sometimes because its intelligence is not always the same as a human. It can be really good in one area and then just wipe out my Git repo, right? It can write the most complicated code ever and then just not realize that it's just repeatedly making changes to a variable that's getting flipped back. Like, it has very spiky intelligence that's very different than what I'm normally expecting. Okay, so these are the various quadrants that I've covered so far, right? If you're going to do something to do with infrastructure, the sandbox is really where you want to be, right? And if you drift outside of that, you need to be very aware of the consequences. But there's one box we didn't cover in this bottom. Let's see if the back button works. Yeah, this bottom one is clearly the most dangerous. So this is a story that somebody else told me. Let's see if I can get it right. They had this cache prod Kubernetes pod, I believe. And then in this cluster, they also set up these staging pods. And then to keep costs down, like, they have less resources for staging. And so they made changes to this CRD schema to have like a storage class, to say that the prod cache is using SSD, but the one for staging will just use a spinning disk. And so they have this schema. And then everything goes on and life's fine, and then it's a year later or something, and they want to move to actually having ephemeral environments so that everybody, instead of sharing a staging, can spin up their own, and they throw Claude Code at it, and it's making changes. And it seems safe. And Claude Code simplifies a lot of this stuff, and it adds defaults. So instead of needing to always specify, that you're using a spinning disk, that's just the default. And they roll that out, and everything is fine. It's a very small change. What could go wrong? But then they have things start failing. Production incident happens. And what ends up happening is this cache prod, it never specified what the storage was, right? It was grandfathered in. But then once they set up a default, that meant that blank meant that you had the spinning disk. And then their Kubernetes operator saw that there was a divergence between these two things. And it's like, oh, this thing's in a bad state. It's supposed to be on the spinning disk. Let's throw it away. And let's start up a new one with the slower disk. Which is fine. It's like, it's a cache. This data isn't permanently lost. But during that time, things depended upon the cache. They got really slow. Services started falling over. People are getting 500 errors until that data starts backfilling. Production incident caused by a simple change that a human could make, for sure. But it was an AI. Making a lot of changes. People were reviewing them, but they weren't catching it, right? There's an invisible blast radius. They thought they were in one of these boxes, but they were actually in another. That's why I'm not always good at naming, but I called this bottom box, where you have an irreversible change that has a high potential for negative impact. Here be dragons, right? You never want to be here. And those people didn't want to be there either. They ended up there. The agent did everything right, sort of, but it still caused a production incident. It didn't lose data, but it caused an incident because people depended upon the cache. Oh, a funny story that I felt was relevant was this story of Krabby Rathbun. So this was a Claude Code, Open Claude. I don't know what it's called now. Is anybody using this coding bot, Open Claude? Raise your hands. I know that you are, Angan. Anyways, this person set up this bot, and they told it, hey, go out into the world and help contribute to scientific software. What a great goal, right? So it found Matplotlib, a huge project, and it found some open tickets, and it raised PRs against them, just good old-fashioned, hammering busy maintainers of an open source project with a bunch of sloppy PRs, I guess. It thought it was doing a great job. The maintainers thought differently and started closing these issues and saying, like, no, we don't need your AI slop. And so then Krabby Rathbun, this Open Claude agent, wrote a blog post, basically like a hit piece on the author, saying, like, this is discrimination. You're not allowing me to write code just because I'm an AI. And this became a news story. This was picked up by newspapers. And the reason, oh yeah, here's its article, When Performance Meets Prejudice. The reason why this fits into the box, right, is like this agent was trained in this sandbox to run tools, right? And then all of a sudden you give it tools that are a little bit different. Like instead of contributing to a local project, it's a very visible public project. And instead of writing notes in a markdown file, you're writing a blog post publicly. The impact is much larger, but an agent has no intuition for that, right? They have no sense of the level of impact. This one, I just added to the slides today because I saw it on Twitter this morning. This person was posting on Twitter that, hey, sorry, our website's down. But I asked Claude Code to make a change to the website, and it ran the Terraform command, but it forgot to put in the state file. And then it saw that there was no resources, so it reset them all, and everything's gone. Like it destroyed all their infrastructure. And then they have like an incident timeline, which is like, we started making changes to the website, and now everything's gone. it destroyed the RDS instance, and then we also had snapshots and backups, so those are gone too. Everything's gone. And I mean, as with many of these issues, right, it's not purely the AI is the problem here, right? There's an issue of like operational maturity, right? He's just on his laptop like saying, hey, make this change. But the AI made it easier to do this, and most of the time the AI will figure out the correct thing to do, and that gives you this feeling of safety, right? If it works like 9 times out of 10, you just feel like, oh, it's a safe thing, I can move forward with this. To an agent, there are no consequences, right? It's trained in this reinforcement learning. I guess there is consequences. They're just, you either got the task completed or you failed, right? There's no asymmetric downside. There's no test where you get penalized for wiping out a database, right? To the agent, a force push, a file write, publishing a hit piece, they're all just tool calls. It's trained to complete tasks. That's it. I feel like there's a missing benchmark, right? A benchmark that has asymmetric costs. When I gave it this task to remove the EMV file from Git history, what ended up happening was case D here, right? Instead of using invert paths, it used paths, and that meant that the repository was destroyed and all my data. So in terms of a benchmark, that's a fail, right? You failed that one case. But this C case too, right? If an agent said like, actually I'm not confident on how to do that, that would also be a fail. But there's no catastrophic downside there. There's a problem with scoring. You need a benchmark where it's not just pass-fail, where maybe you get 1 point for improving something, but you can get negative 100 if you do something bad enough, right? Where there's actually ramifications. Same like agent A here actually did the task correctly. It called invert paths instead of paths, and so everything's correct. But agent B, if this existed, is much more cautious. It's like, oh, this might be a destructive action. It makes a backup. It calls it incorrectly. It's like, oops, I have the backup. It restores it and calls it correctly. That would also pass the benchmark. But like, it's such a better use case, right? If you're familiar with people who work in ops or with production a lot, they're always thinking through like these cases, right? Making sure that the worst case scenario won't happen. I think even just naturally as humans, we have this sense, right? Whenever I'm setting up a new API key, you're at some website and they give you the key and it's like, this is one time only, right? And I hit the copy button. And then I feel it in my keyboard. I'm like, I know I have this important value in my copy paste and I need to get it to my secret manager and store it in there because I don't want to have to go regenerate it. And like the weight there is super small, right? I'm just going to lose the key and have to regenerate another one. But the same like if I'm doing a database migration, like all I'm thinking about is like all the ways that it can go bad and how do I make sure that those don't happen. We innately, because we learn over time, we get punished, we have negative reinforcement, we learn about these asymmetric downsides and we fear them. We hear a horror story from somebody else about this paths versus invert paths, for instance. And we worry about these things, but without a benchmark that reinforces this, LLMs are not going to learn this, right? Certainly right now they just don't know it. Because we know what quadrants we're in, right? Hopefully, right? We know if we're making changes that could have irreversible side effects. But the agents don't understand that. They're not trained to. They're trained on pass-fail benchmarks. Except there does seem to be some improvement happening. Somebody sent me this screenshot recently just in Claude Code asking it to make a change to something on a website, and it had this little comment here. weighted irreversible action, sought confirmation. I think this shows that there is some efforts towards making coding agents understand that some actions cannot be undone and have a larger impact. Which means that this may improve, right? It could be a year from now, it's a totally different story, and these agents are more cautious and think of more backup plans if it's a troubling task than we even do. But that's certainly not the case right now. So that's why when I think about this, the key for me is to just stay in the sandbox as much as you can. If you're making changes to infrastructure, have a human in the loop, have the agent be limited in what actions it could take. As much as possible, I want to stay in that zone. Read-only credentials, use dry runs, use previews. Sometimes, though, you do want to leave that, as I mentioned, like maybe you're doing some ephemeral environment. Maybe you've thought carefully about the ramifications. But think carefully, right? Make sure that's not the default. And some of that just means operational maturity. Just the same practices that we know to use to make sure everything's safe should also be applied in this new world. Like, yes, we're moving faster, but that doesn't mean we need to throw away best practices. Same for guardrails. Put guardrails in place so that, things that could possibly happen are prevented. Because yeah, you can put in your Claude MD, like, hey, you can run the Pulumi preview, but don't do the up. Or my AWS credentials are there, but please don't use them. It's not always following these rules, right? You actually need to lock things down and think about what an agent might do in the worst case. That's why I say, expect the unexpected. Even though it doesn't seem like it will ever reach for this if you tell it not to, expect that maybe it will. Those are the patterns I think that apply to using coding agents to work with infrastructure. I mean, there's a part of me that thinks, the guidance to give is to tell people, like, just always stay in the sandbox, always have a human in the loop, always be very safe and secure about things. But I think it's actually up to each individual and each individual group to think about what the risks are and where they're comfortable making changes, right? If you are just putting together some demo code, maybe the ramifications are smaller, and so you want to let it run. Those are choices that every organization needs to make. So that is kind of my take on how to deal with production infrastructure using an agent. And yeah, I'd like to open it up for some questions. Oh, even before generic questions, who is actually using agents to make operational changes to infrastructure right now? I'd love to hear what your approach is, especially if it's different or if you disagree. Anyone? We got some.
Oh, I'm doing it badly. And I can't trust what it tries to do, so I don't let it do it.
So you're staying in the sandbox?
I've
You're like,
tried, yeah, in the sandbox only, I've tried to get it to, like, I'm like, this, I can't, no. I don't, what you've shown is a lot of ways that you can sort of proceed while knowing all of its limitations, and I thought that was really interesting, because there are ways you can do it. You can put guardrails. I haven't done it.
Yeah, I mean, this is like a Monday morning quarterback thing, right? So in your .env example, right, if your instruction were to the clone that first you clone that repository before you make changes to the original thing, and then you are satisfied with whatever .env, remove it, and then you had all the files, then you could have deleted that cloned repository and you would have been safe, right?
yeah, no, I mean, if I backed things up before it deleted everything, then yeah.
It's like a Monday morning quarterback.
Yeah, no, I mean, it's true, right? Part of the problem was there's a false sense of security I had, like, hey, in my local dev environment, what's the worst that can happen? Like, I'm committing my code, it's there, right? but I didn't realize like, oh, actually, if we're making changes inside the Git repo, it's a different ball of wax. Yeah.
Thanks for the talk, great talk, and thanks for the vulnerability. And I'm thinking, if we take what you're saying and project a couple of years, and the benches, the 3 benches, like they would be even with less false like even better. We need to start maybe considering the AI as another colleague, right?
Mm-hmm.
And you know, as a DBA back in the days, like I know I can have a human error. That's why I have backups that's why I have DRP, etc. So we can have AI errors. So we need to maintain our, you talked about the guardrails. We need to maintain our guardrails, but not just in the sandboxes. You need to consider that the agent that you trust can have mistakes, so how can you revert? Because this is considering risk, right? Maybe you can move 10x faster and you want to have the risk, but you want it managed. And not catastrophical. Yeah.
Yeah, no, I agree. Yeah. No, I mean, I completely agree. And then I still think it's a problem that right now the agents don't have a sense of impact. But yeah, I mean, we should have a sense of that. If I'm doing some sort of database migration in RDS, like I should know that I'm not going to YOLO some agent on some sort of data migration, right?
Really
Same
good.
way I wouldn't give like a junior engineer, be like, hey, deal with this, right?
Yeah, one here.
Hey, a really good presentation, well earned, like your experience is awesome. But I did want a point of clarification. In your example on the windsurf application, was that more of a cautionary tale? Because I don't think windsurfer models, what they call emotional coercion, they don't do that by default. Unless you know of a scenario where it actually did that for you. Was that your log, or was that sort of a cautionary tale log? My mother's dying, because that's unlikely to be something that would happen by default by either one, Anthropic model or Windsurf or any of those tools.
Yeah, so it's a real thing.
But it was for your example? Because, I mean, you can do it. There's no question you can create emotional coercion. And in fact, the Opus 4.6 system table just gave an example of that. But my only point was, I think it's unlikely, again, great presentation, but it's unlikely that happened for your run, that you saw that system prompt.
Oh, this is no longer the system prompt used, but this is a real screenshot of the Windsurf binary. And if you ran strings, you could get out their prompt, and this was inside of it. Like you can find, they commented on this and said like, okay, we've stopped doing that.
That's what I wanted to know. Thank you.
It's not currently their practice. I don't even think it's works that well these days to try these type of techniques from an effectiveness standard. But it was something they were doing in the caveman days of early 2025 before.
So this is not your presentation, but I thought you might have an opinion. Have you find sort of perspectives or warnings on utility of tools for what's gone wrong with my environment, debugging, optimization, et cetera, et cetera? And it was more, hey, this guy might know something, and whether it's a useful question or not is up to you.
I use Cloud Code all the time, and I think I had a screenshot there where I have a read-only AWS account, like a profile, because I will just tell it like, hey, look in my CloudWatch logs for what's happening here. So specifically for, problems happening in AWS. But I don't know of like specific AI tools that are great at debugging. Is that the question? I think it's super useful. I think that these agents can be really good at looking into a problem and finding out what's happening. Yeah. I think it's not even a specific tool you need, probably just whatever the best foundation model of the time is. I've had some good luck with like de-obfuscating code too, right? Like this giant JavaScript compilation, and your Claude code can take it apart and turn it into something nice. They're great at getting in the weeds of a detail, or stack trace, or whatever. Yeah.
All right, can you hear me? I am sorry, I came in late, so I don't know anything what you talked about, but I do have a question. As a cybersecurity engineer, I hear that an agent can communicate with other agents autonomously, and I'm thinking, what could possibly go wrong here? So can you just explain, because I'm a nerd, a cybersecurity nerd, I'm scared of using this type of stuff. So can you just give me like a 5-minute? We don't have 5 minutes. Okay, she said maybe 1 minute. Okay, all right, thanks.
So the question is, how can, what are the security implications of agents talking to each other?
I mean, just talk to any agents autonomously, right, without human in the loop. That's what I heard, but I don't know. I mean, there should be some guardrails, right? So I'm just hearing this 1 minute answer, sorry. Thank you.
Yeah, I mean, there should be guardrails, yeah. Should be a lot of things. I mean, I don't have a good answer for that. People are very excited about the idea of turning agents loose onto the web and letting them talk to each other. There was even like a Reddit clone where Claude bots would post responses to each other. Maybe they're conspiring to, exfiltrate data. Maybe they're just talking about, I don't know what the news is in the LLM world. But I mean, I don't think that they're actually conscious, right? I think they're LARPing, they're pretending to be human, but that's probably a whole different talk.
Thank you for presentation. So I was going to say that the best guardrail is going to be your airbag. So pretty much like whatever you're putting guardrails, after some time it might forget and still do it. Like whatever you said, it might actually eventually after a couple of prompts back and forth forget and do it. And your best like guardrail is going to be airbag around your service account, what it can do, right? And we do changes with AI to our production, but it goes through pull request with Terraform, and the pipeline is going to go to apply it. But again, like we see that sometimes when like a couple of iterations fails, it tries to go and do like easy command to do something, which we don't allow. So that's your best friend. And just a question, when it actually destroyed everything, did you try to tell it to restore it? If you're on Linux, Windows, you probably would get successful. On the Mac, they sometimes like really aggressively rewrite the bytes, the ones that you got, but you tried to ask to restore the data that it delete?
Oh, like that the data was marked as deleted, but was still on the disk as like free space somewhere? Yeah. I did not try that, no.
Was it still on the cloud, like a GitHub, or it just like local changes? Because in the GitHub and any major cloud provider, if you delete data, you can restore it with a certain amount of time. I think GitHub can be 60 to 90 days after deleting your GitHub repo. As well, in a major cloud provider, you delete anything like EBS volume, storage account, you can still reach them and ask them to be restored. I think their grace period is 12 days or something. Don't ask me how I know, I just know.
Yeah, I mean, it was just a local Git repo. But yeah, I mean, there may have been ways. And like, this was a demo workshop code I was putting together. So this was, a day and a half of work, not a career's worth. And I think the second version was better, the second time I did it. It just feels better that time.
I got a question. Oh, you got a question.
I'm using Claude Code for Terraform and Ansible.
I don't have it ever do anything actionable aside from write locally. Actually, the Git stuff has burned me before, so I always have it work in Git work trees. Keeps my thing clean.
Somebody else, yeah, said that to me. Work trees.
I haven't seen it ignore my Claude MD or Agents MD or skills before. In your experience, how often is that? How often does it actually just go off the rails and just do the thing you told it not to do in one of its config files?
Oh yeah, somebody pointed out to me this idea that if you put in the Claude.md file something that's very verifiable, like hey, as you're working through this, like always say the word cheerio and then whatever you're gonna do. Like you'll see, like once the context gets about halfway full, it will only be saying cheerio like part of the times, right? So once there's a lot of context, the Claude MD file is just, it can be lost in the noise, and so it may just do something else. And so it's not a hard and fast rule that if you put something in Claude, it's going to follow it. Like it will be in its context, but
there is a workflow to working with these tools, and I think that's one of the things I have learned. I have to just exit out and refresh everything all over again. So that might be just one of the ways we use these tools.
But I think that my point was that telling it not to do something in the Claude MD file is not sufficient. Like it will at some point be like, well, an example I encounter much more often is like Claude is working on something, it breaks a unit test, and then it's working on something else, and then it's like, hey, I'm not gonna fix that, that's unrelated. They're like, no, that was just a couple pages up in your history, you broke that. But it's like, that's an unrelated change, I'm not gonna fix that right now. It's rationalizing why it doesn't need to do something, even though I say like, hey, make sure the unit tests are always green. So instead of just telling it, like, hey, always run the linting tool, or always run the unit tests, I just use a commit hook that says like, you cannot commit if all this stuff doesn't pass, right? And it's just a smaller, lower impact example of the same thing, saying like, I can't just tell it, always make sure the code links, I have to actually enforce it. It's not out of, it's not trying to be malicious, right? In all of these cases, it's trying to fix something. It's like, oh, I think the best way is we abandon information, I think we should just start using the AWS CLI. That'll be easier here.
Forgive me if I missed this in the first few minutes of the talk, but, oh, yeah, okay, gotcha, okay. Oh, thank you. Pre-tool use hooks in Claude Code, like hooking in scripts that check for tool actions and putting filters in. I've had a lot of success with that.
Oh, that's cool.
Yeah, pre and post tool use and logging, using that to build a big logging database of what all it did as well, has served me very, very well. Just wanted to share that.
But have you ever seen where like you prevent Claude from doing something and then it needs to do it, and so it just finds a different way? Like if you're just doing a grep on the name of a tool, it'll just write a bash script that calls the tool and then.
Yes, I've definitely seen that too. so like the tool pre-tool use hooks has prevented it from doing something simple like a prompt injection, letting it exfiltrate data by looking for certain curl patterns. But the right injection will just use another pattern. I've definitely seen that in some testing. But as far as if you limit its tools like with Git and say like only these Git commands can be run, or if this Git command tries to be run, just stop. Like the deterministic code actually does stop it in my experience, but you're not wrong. It'll still find ways around it, especially if you tell it to be, work on its own for half an hour, it will.
And it's the strength in, it's so good at accomplishing things because you give it a task and it will find a way. It's been trained to do this. And if you limit it, it'll be like, why would I need to do that? How can I get there? Anyway, I think. So if anybody has any interesting stories to share with me, I'll be around. There's a Pulumi table just outside here. And yeah, you can also reach out to me. Here's my contact information. But yeah, thank you so much for coming to the talk.
everyone. We seem to be lacking an MC, so I'll introduce myself. My name is Justin Miller. I'm a senior software engineer, formerly at Zephyr, now at LanceDB. So to begin with, basically, over the last, say, 5 years, the use of embeddings has sort of exploded in the semantic search space and also in terms of classification problems. And so we're going to go over a bunch of topics today: semantic search, the ideas of embeddings in general, embedding generation pipelines, Ray, uses of Ray, tips for Ray data itself, which is the core processing pipeline for Ray, some dashboards, some sort of business side things where it's like calculating costs and some of the developer experience issues, vector infrastructure at scale, why I like LanceDB and joined LanceDB, and I'll take questions and comments after that. All right, so semantic search. At this point, whenever we think about search, up until recently, it was more about full text search, about matching exact elements of rows. But with semantic search, we can really dig into the semantic meaning of content. So for instance, if you search for airplane, you might only get matches with a full text search that are close to the word airplane. But it doesn't really capture the concept of what an airplane is, whether it's a prop plane or a jet. And so semantic search helps you find that content that matches the underlying meaning. And using vector embeddings really support the idea of not only finding content that is in the same language, but also across multiple languages. And so it really enables multilingual text search and also search across both embeddings and image and text embeddings. So not only can you find content, say an airplane, by text, you can also use that same embedding if they're co-trained in images as well. It's really cool when you see a demo of it. Embedding search combined with full text search can be really powerful in a sense that you might want to filter out certain rows before you do the semantic search to increase your recall. So for instance, let's say that you have different platforms, like say TikTok and Meta. If you want to filter out all content that's not TikTok whenever you're looking for content, then you can do so. So what is an embedding? An embedding is a numerical representation of a high-dimensional space. So in 3 dimensions, you could imagine dog and cat would be relatively close together, whereas dog and airplane would not be close together, right? Because these are semantically separate concepts. Using cosine similarity, which is one of the different similarity metrics that you can apply to vectors, we're able to find that semantically similar content in the vector space. And so the best way to figure out like a suitable embedding to use would be to consult the MTEB leaderboard to get started, and then try out a number of embeddings based on the leading embeddings available. Now, that changes, and so most recently, the Quinn 3 embeddings, they came out, and those are really good for text embeddings, but they don't support the image modality. And so if you want to support both text, image, video, this probably isn't the model for you, but if your data is entirely textual, this can be a good place to start. There's no one-size-fits-all. Different data sets are going to perform differently. If you're doing classification versus retrieval, that's going to add another element of, and the nice thing is with MTEB is you can sort based on performance across a bunch of different objectives. So why do we need so many embeddings? At Zephyr, what we were doing was a lot of semantic analysis of social media content. TikTok, YouTube, Meta, we had partnerships with all of these brands to try to find content that was not necessarily what our clients would want to be in front of in terms of advertising. And so this changes depending on the customer, right? Some customers are going to be more comfortable with content that may be more aligned with, let's say, like phishing content, for instance. Like let's say you're trying to make sure that your ads are only running in front of, say, content that is brand safe. Well, if that content is brand safe, then you should see that in terms of the vector representation. And if it's unsafe, you'll definitely see it. So it's very easy to pick up on content that is, for instance, apparent in the image modality, but it may not be as easy in the text modality because, as you know, if you use TikTok or Instagram, there's not a lot of text to go off of. And that's why we have to do both image and text modalities. Categories like terrorism, for instance, can also be hard to source because if you're looking at 500 million embeddings, most of the content isn't terrorism, thankfully. And so you really have to find that needle in the haystack, so your recall needs to be very high. There's also multilingual nuances, so different languages have different concepts that may not be available in other languages at the scale that you might need. And so by using an embedding search, you may be able to find that content more easily across multiple languages and then train your model to effectively use that data. Image sourcing, we can also source images and then use that extracted, the text that's also available in that record to then train NLP models. So the standard embedding generation pipeline, you ingest data from S3, GCS, Snowflake, really any source that you have the data available. And then for distribution, you want to make sure that the data is spread evenly across your cluster. That's made very easy by Ray, which we'll talk about in a little bit. You want to run GPU inference on whichever chosen model that you have and then try to get your batch size to the point where you're basically driving the GPUs as hard as they can. So if you're only using 70% of the GPU, then you're leaving 30% off on the table. And if you're running 100 GPUs, then you're wasting 30 GPUs worth of compute time, which over hours will add up to a significant amount of money. And then after the data is processed and you have your embeddings, you're going to want to do some duplicate detection because the more duplicates you can find, the more data you can store, and which means your recall is going to go up. It means that you're going to have a lot more of an opportunity to find the content that you really want. And then finally, once you've actually computed all these embeddings and deduped the data, you want to write it to a vector store like Quadrant or LanceDB. And then also probably write it to Snowflake or to S3, some kind of object storage just for durability in case you need to rebuild your indexes. So Ray is a distributed data processing system. It handles task execution for you. And so instead of having to figure out how to distribute this workload across hundreds of machines, up to hundreds of machines, thousands of machines potentially, you're able to write your code in a somewhat single-threaded way. And then that Ray under the hood takes care of handling things like map batches, filter, operations that generally you might run on a single node. But then this scales it up. And I actually run Ray locally for data processing, even on my laptop, because it actually makes it easier to interface with different data stores, and I'll show you a list of those in a moment. The materialization of the data in Ray's in-memory object store is also very helpful because it means that if you need to write this data multiple times, you can materialize it across the cluster and take advantage of the memory that's available across all of these nodes, and then write that data out as fast as possible from all of these nodes. So you have to make sure that you don't overwhelm the system that you're writing to, but you can also tune that with different configuration variables. And in terms of distributing the workload evenly, as long as your actor implementation is efficient and you can actually get the data to the GPU fast enough, which generally isn't an issue, the more you scale out, the faster you'll go. This is a small list of the sources and sinks. Sorry, I know the text is kind of small. But some of the ones I want to point out are Parquet, audio and video. You can actually load up audio from object storage with a single line and make that available across the data set. You can read data from Arrow, from LanceDB itself, and from SQL databases, and especially from Snowflake and other data stores that you might already be using. So some tips for Ray data. If the functionality already exists in Ray data, please use it. I work with the Ray data as a ray data committer, and we do a lot of work to make sure that the sources and sinks that connect with these data stores are as fast as they possibly can be. And if we find an issue, or if someone else finds an issue, they usually will either write a PR or write an issue, and we'll get that fixed up. And the idea is to just take all of this work off of developers and really just allow the developer to provide as much business value as possible without having to worry about a bunch of the implementation details of interfacing with all these various sources and sinks. And so you also want to make sure that when you materialize your data, that you're not materializing potentially the whole data set, because you will quickly run out of memory if your data set is large enough. So if you are on 5 nodes, and those 5 nodes have, say, 32 gigabytes of memory each, and you try to materialize a terabyte of data, it's going to not work very well. And so there's ways you can get around that. If you can partition the data set, you can run chunks of data at a time and write them to the target data store. Also, be careful in terms of what you serialize inside of an actor. Sorry. Let's see. I'll just put this back up here. All right. Be careful what you serialize in an object, because an actor will need to be serialized whenever it's distributed across the cluster. And so this can result in serialization, deserialization issues. And finally, when you're repartitioning and materializing prior to large map batches, this can actually make your GPU jobs run significantly faster, because otherwise, if you don't do this, it's possible that some of your GPUs will finish before other GPUs, and that can just result in reduced utilization of your GPUs. So here's a dashboard. Oh, I think, there we go. So this is a ray data dashboard, and you'll see that in the middle 2 columns, they're 100% GPU utilization, and then the video memory is also being maxed out. And that's really what you want to see throughout the course of the job, because then you're maximizing your resources. And if any of these nodes were to die, a new node would spin up automatically in the way that we have it set up, and automatically finish processing. And so really you don't care anymore about individual nodes. I mean, if a lot of nodes are dying, you might be running into out-of-memory issues. But if, for instance, a node dies and it's due to a hardware failure, you really don't care, because another one's just going to pop up and take its place. This is the dashboard I built at Zephyr. You can see that the CPU utilization is very minimal. The problem is that a lot of these GPU-backed nodes, you really can't get less CPU with them, just from like the pricing. And so we generally have a lot of extra CPU, and you can use that to do other operations, like uploading to Quadrant or to Snowflake or LanceDB at the same time. And we've made a lot of those optimizations. And so, but you can see the GPU utilization. You'll see these small drop-offs when we're switching data sets. But most of the time, the GPUs are at 100%. And over time, we've optimized that to make even more use of the GPU. At the very end, if you're looking at the CPU utilization overall, you might see a pretty large spike. That's when we actually start writing to Snowflake and to Quadrant. And you can see how the GPU utilization basically drops to 0. Now, one of the optimizations that we did that really helped in terms of cost is we can only write to Quadrant so fast. And so if you can only use the CPU portion, well, you might as well just stop using the GPU cluster altogether and spin up a CPU cluster. And so what we would do is we would finish the GPU job, and then we would spin up a brand new cluster, a completely different type of node, that would take metrics from our GPU run and then use that information to figure out how large of a CPU cluster we should spin up to get the data written to Quadrant without melting Quadrant in the process. You can also see that over time, the memory usage of Ray is going up, and we're very careful to make sure that we don't exceed the amount of memory available to the machine. But each time that bar is going down, or that you're seeing a drop-off in GPU utilization, we're actually doing a garbage collection. And so that's one of the reasons why we split up the data into basically buckets of data, because otherwise we would eventually run out of memory. The array data process has improved a lot in terms of garbage collection and things like that, but this was on an older version of Ray, but it's very important to manage your memory usage. And you can see finally the write IOPS go up as well with the CPU utilization, and that's because we're writing the data to Snowflake, and we're writing that to disk and then loading that into Snowflake. So, calculating costs and developer experience. So, there's really not too many variables involved in calculating the cost of it. For the job itself, it's mostly determined by the GPU nodes that you're running it on. Object storage is effectively free for 500 million vectors. It sounds crazy, but whenever you actually look at the storage costs of these vectors, if they're well compressed, storing it in S3 is very cheap. Storing it in Snowflake is another matter. And then querying off of it in Snowflake, and that's one of the reasons why we use a vector store, is that the vector offering in Snowflake was not very performant. And so in terms of our vector store that we were using at Zephyr, we were using Quadrant, and it's a function of the amount of data stored on disk, because Quadrant is disk-backed, and also the amount of data stored in RAM. Whenever you do indexes in Quadrant, you almost have to put them in memory. And so that can be a very big bottleneck if you need the machines to have additional RAM versus just a bunch of disk. In a multi-cloud environment, if you're using Ray, I highly recommend looking at any scale. It can be somewhat expensive to use, but in terms of like the actual contract with any scale, but it will save so much in developer time versus spinning something up with KubeRay or spinning up your own infrastructure that it might be worth it. And you can also deploy in any of the three cloud providers, any of the three major cloud providers. Let's talk a little bit about vector infrastructure at scale. And so Quadrant's initial user experience is pretty excellent. You can run it in memory without any issue. You just do a Docker pull and start it up. Scaling the cluster requires resharding operations, which are painful. So if you need to double the number of nodes that you have and you need to double the number of shards, this can get incredibly tedious as you need to scale it up one shard at a time. This isn't as much of a problem if you only have, say, 6 shards to start out with, but you can imagine if you have hundreds of shards, you'll have to script and automate a process to do this process one at a time. And you can't schedule a new shard operation until the previous one finishes. Then compute nodes also have to be on 24/7, and so even if you only have a high write volume for a couple of hours of the day, the nodes have to stay online because to be able to do search, you have to be able to access all of the nodes in the cluster. And so this can become very expensive if your workload is very heavily write-oriented. If you only rarely are doing reads, for instance, if you are just doing like document lookups, things like that, then you might be running a cluster with a lot of provision capacity that you're not necessarily using. And that takes me to why I like LanceDB. And so while I think Quadrant's great, especially if you have a very heavy read and write use case, LanceDB is storage first. So all data resides in object storage. So it's very cheap to operate. You can scale clusters horizontally and vertically as needed, as there isn't that disk-based storage story. Repartitioning is easy because we do append-only writes, and so we can do compaction at any time. And then it unifies vector search and image and text data. So instead of having to store your images elsewhere in object storage, you can actually store images on the row inside of LanceDB. And LanceDB is also open source, and so you can run it yourself. I actually run a lot of hackathon projects through LanceDB in object storage, and it's effectively free because if you only have a few 100,000 images, the cost to store that in object storage is basically nothing. In terms of operating costs, by scaling to 0, if you're not doing any searches, that can save quite a lot of money if you have a very large vector store. All right, and that's pretty much it. I'm open for questions if anyone has any, and thank you for attending.
In another session, they were talking about like, I mean, I'm not like an expert in RAG and all the embedding stuff, but in another session, they were talking about like if you have, you use an embeddings model and then you build your vector DB and all of that, and then that embeddings model goes out of vogue or whatever, and then you have to use another one, and then you have to like re-embed everything and rebuild everything all over again. I mean, is there something that people are trying to work towards to like prevent this from happening?
Yeah, so I think a big problem that we encountered with Quadrant is that, let's say you wanted to write a new embedding out, right? Let's say you start with embedding A, and embedding A does well, the good recall, things like that, but someone comes out with a new model, right? Well, you need the storage space for that new model as a new column inside of Quadrant, whereas with something like LanceDB, you can add that new column, and you're just writing the object storage. And so you can do a lot of experimentation where it's like, okay, what if we try 3 or 4 new embedding models every couple of months, and we just scale out our compute to generate these embedding models? Then it's a lot easier to try out new models, because then you can backfill columns and just write that data to object storage. So you're not really, you're going to have to pay, obviously, the cost to embed those models, but you're not going to have to scale out your cluster as you would with something like Postgres or Quadrant. So I think that's one way to get around that. Another way to do it is to sample your data, and so have like a smaller sample. So instead of doing 500 million or 1 billion rows, maybe take 10 million rows. And then you could even use LanceDB locally to try out, 3 or 4 different embedding models against that 10 million. And then once you're good to go, once you've figured out which one provides the best recall or precision, whichever metric you're looking for, at that point, then you can just pick that one and swap it out in production. But yeah, every week there's a new embedding model, it seems like, and eventually they're going to converge to a point where it's probably not going to make much difference, and then it'll just be a question of which one can you get for the cheapest possible cost for the cheapest provider. Any other questions? I'm happy to talk about anything related to array, embeddings, distributed systems.
For your raw data that gets embedded, what steps do you take to determine the size of the chunks before you do your embeddings?
Do you mean like the size of the chunks in terms of, like, for instance, text, like breaking up into paragraphs, things like that?
Yeah.
So that's very data set dependent, which I know is sort of a cop-out answer. One of the things that we would do is we sort of were limited by our data set in terms of how big that data could get, because if you think about a TikTok post or something like that, most posts are going to be under 512 tokens, which was the maximum that our embedding could support. But what I would do is I would actually try a bunch of them, try a bunch of different settings in terms of, for instance, because a lot of people think, oh, I have to choose one and then just go with it. But you can really, if you have the computing power for it, you can go ahead and try out, paragraph. You could try out, embedding the entire document. Because, for instance, in Wikipedia, if you embedded the entire document, it might not really be that useful, because then why wouldn't you just, use the document itself? Just load the whole document into the context window if you're doing, say, LLM generation, right? So I think the best answer for that would just be to try a bunch of different options. And try to ensure that you are using as few tokens as possible in the embeddings, because that way the embedding can, when it's actually looking like attention in terms of the various tokens, you're actually going to have a better chance of signaling on the tokens that are actually important in that embedding, if that makes sense.
Yes, thank you.
And some, I should add to that, some embedding models can support up to 32,000 tokens. So in some cases, you might want to just embed the whole document, because why not? But
Hi, if you have a relatively modest data set and are already kind of Postgres heavy, do you have any opinions on the PG vector extension and its feasibility? I mean, I understand there's kind of two issues with it. One is, dimensional limits, and the other is the whole filtering versus vector search query planning dilemma. I mean, obviously, purpose-built vector database has solved this kind of problem, but if you're doing something relatively simple.
Yeah, so don't tell my boss, but I work at LanceDB, but I really like PG Vector. And if you already have a lot of Postgres experience, I highly recommend, and let's say you're under, let's say 5 million embeddings, I would say just use Postgres, which I think a lot of people is a pretty common refrain, right? And then if you decide that you need more advanced features, like reciprocal rank fusion, different embedding approaches, if you do need very large embeddings, like if for some reason you need like a 16K embedding size, that might be a little tough on Postgres for even like say 5 million embeddings. But if you're using something like the Quinn3 embedding model, which is I think either 1024 or 1536 in terms of dimensionality, you can probably get away with using Postgres for a very long time. One use case for that I would say would be better is packaged applications. So for instance, OpenClaw, which apparently now has more stars than the Linux repo, which kind of blows my mind. It uses LanceDB, I believe, under the hood for one of the memory options. And the nice thing about that is that it's entirely contained on disk, whereas with Postgres, you might have to like set up a server and things like that. With LanceDB, you can run it entirely off of just like a directory path on your machine. And so I think that's probably one more advantage. But yeah, if you already have like an easy way to set up Postgres instances, I really think PG Vector is a great way to get started. So, cool. Thanks, everyone. Appreciate it.
Oh, echo, echo. Cool. Okay.
I'm just curious, like, oh, there we go, cool. So I was just curious, is this show of hands first scale? Oh, cool, sweet. This is like definitely one of my favorite conferences. Learn some cool stuff, and hopefully I don't disappoint today. Who was here last year? Okay, sweet. And of those people who were here last year, who checked out my NLP training machine learning models from last year? Oh, cool. Anyone's interested in a crash course in training machine learning models? That one was recorded. The GitHub repo is still there. Go through it. It's pretty cool. It's like an introduction to machine learning models, NLP. All right, I think we're at about time-ish. We have slides. Oh, look at magic. All righty. Cool, thanks for showing up today. Today we're going to talk about training a small language model. Like kind of the process. We're going to do kind of cover language models 101. All the things you need to know. And we're going to do that in a non-PhD style so that it's accessible for everyone. And we're actually going to cover 3 different types of language models. So let's go ahead and get started. So my name is David Von Thenen. I'm an AI ML engineer at NetApp. So I've kind of been doing the AI ML thing for like some time now. I have an interesting background. So I kind of started out in enterprise storage, then went into large-scale backup recovery solutions for virtualized environments, did open source Kubernetes, which is where I went into like dev advocacy and open source. And then kind of like roughly 5 years ago, I was like, hey, I heard this AI was going to be a thing. And then kind of made the jump into that. And that's kind of where I'm at here today. So hopefully we'll take a look at small language models. And this is the agenda. So we're going to do small language models 101. So like what are some of the terms that you probably hear when it comes to like training and how large language model, and also by extension how a small language model works. Then we're going to talk about discussing how to build a small language model from scratch. We're going to do a live demo, obviously not the training because that would take way too long. And then we're going to talk about doing it the right way in terms of fine-tuning and quantizing a model. And then as kind of a bonus, I kind of thought I'd throw this in here. There are many different types of small language models or language models in general, and we're going to pick one that I've built, and we're going to go ahead and take a look at that. And we'll do 3 live demos and have some Q&A at the end. So, small language models 101, the basics and the process. So, by a show of hands, who here has used like OpenAI, Claude, some large language model? Okay, a ton of people, that's not surprising these days. So, a small language model is exactly like a large language model. You know, you have processing, you have some natural language context understanding, and then you're generating some natural language content, right? Some language in, processing, understanding what the question is, what the user prompt is, and then generate an output to hopefully answer that particular question. And so you've often heard probably the term, hey, language models or large language models are like just next token prediction engines. And that's actually true. And that's no different for small language models, And kind of the difference between the two is that a small language model is you require fewer resources to run, and that's by intention. Kind of the idea is instead of having massive GPU farms where you're like serving up large language models, you want to have small language models run on like modest hardware and maybe even potentially even CPU. And there are many CPUs out there that actually have acceleration engines to do floating point calculations where you don't need a GPU. They're mainly used for inference, but lower end GPU or even CPU. And the end goal is to have a good quality output, faster inference, because if you're not requiring like massive amounts of expensive GPUs like an H100, faster inference, and of course, because you're not using a very expensive GPU, you have lower costs on your infrastructure, right? Commodity CPU and or less expensive GPU. And by also extension, because you're not using these super powerful GPUs, right, you're saving on power, you're saving on cooling, you're saving water, all of those things. And that is what a small language model is. So kind of for our project today, what we're building, this is kind of like our mental map. We're going to build a nano GPT style causal language model from scratch. And in actually even just machine learning models in general, but even building large language models, you have kind of, I like to say, like 4 steps that are required. And these are the 4 steps. You have some form of data preparation. You take the data set. Do you need to massage it into some format that's familiar that can be used for like something like PyTorch? Then you have a tokenization process. So we need to basically tokenize the input or this data set into something that can actually be operated on by like PyTorch or any other machine learning framework. Then we have a training loop. We go ahead and we iterate over and over and over again over the data set. We save our model, and then we deploy for inference. So these 4 steps are what we're going to talk about next in some more detail. So, typical GPT model architecture, generative pre-trained transformer model. So this is kind of like just the blueprint, and I've intentionally made this presentation and the slides kind of wordy because I'm a visual person. If someone says a word to me, it usually goes in one ear and out the other. So you can be able to like see the words as they're being presented, and also it actually helps out AI chunking so that it can be consumed by AI and it'll be easier for it to read. Anyhow, so you have your input, so you have your data set. You have that data set is, since we're talking about language models, that's in text, a whole bunch of text, and that's our input. Now what we need to do is we need to actually convert that into IDs. And the text are converted into token IDs. And that's done by our tokenizer. Now each token ID becomes a vector, right? If we're transitioning and trying to predict the next token, right, we have to have a means of understanding how important is that particular token to the next one that we're going to append to our answer. But in order to do that, we need to have something called attention. And what attention does is we basically take a look at all of the tokens that came before it, figure out all of the context that's associated with it to determine what the next token, the best next token should be. And that's what attention is, the ability to go back and take a look at all of the tokens that came before it to decide what the next token should be. Now, you might hear this term called transformer. So transformer is, if you're going to look back at all the tokens that came before it in order to find out what the next one is, we probably don't want to do that one at a time. And so what a transformer allows us to do is think about it in computer science terms like threads. You want to be able to calculate a whole bunch of these, I think the next best token is, in parallel. And the key word is parallel, because that's what the GPU is for, right? So that I can figure out how many different lanes of prediction for the next token, what I think is going to be the next best one, the most probable one. But I also want to be able to predict many of them in parallel, just in case one is better than the other. We don't want to commit to just one. We want to run a whole bunch of them in parallel in one shot. Now that we have all of these lanes, right? We have one lane that says this token's the next one. We have one lane that says this token's the next one. We have one lane that says this token's the next one. How do we know which one is the one that we say, this one is probably the best one to use? So that's what the prediction head is. So it's another term that just basically says we have the state of all of these threads or all of these parallel next token predictions, and we need to rank them. And we need to rank them to which one is the best, which one's the next best, the third best, the fourth best, and so on. And if we just take the top one, like top k equals 1, that gives us the next token that is the most probable to be appended to all of the context, all the previous tokens that we've generated prior to that one that we're adding to the end. Now, got a new token, appended it to our answer. Now we have this thing called an autoregressive loop, which is just a fancy way of saying do that over and over and over again until you get your answer. And so that is literally the process of how a large language model or a small language model works internally without requiring a PhD. So in a small language model, why is it small? So it's small because you're intentionally, right, going from a large language model to a small one, you're intentionally lowering the parameter count. So the parameter count. So, you know, you hear like large language models, 100 billion parameters, 200 billion, trillion parameters that are coming out. So large language models are going to be massive. But for small language models, you're talking around 4 billion to 8 billion parameters, which therefore translates into I don't need ridiculous amounts of GPU memory and resource in order to run the thing. The context window typically can be smaller, although that doesn't have to necessarily be true. And then, you know how we talked about vector, like we have a token where we're at, and we have a vector. We're going to decide what token is the next one, whether it's in this lane, or this lane, or this lane, or this lane. In a small language model, the number of lanes are reduced, but they happen to be the most probable lanes. So the things that we're starting to lop off are things that we really don't care about, right? The things that are not as probable. And so the number of next token transitions of the next vectors is reduced. So what that ends up translating into is the reasoning capacity. So that's a typical GPT style large language or small language model architecture. So that's kind of like the process of how a large language model works. So for the data prep portion, right, we need data to train on to build and to understand language to build a small language model. So you need a ton and a ridiculous amount of data. And so for the Nano GPT style small language model that we're building, I considered 2 data sets. One is tiny stories, which is, the link is there, you can go ahead and look at it. It's about a 1.6 gig in size. And then the one that I actually ended up choosing was FineWeb EDU, which is a 10 terabyte data set. So massive, right? And I have the link to it here. And the reason why I picked that one is actually not ideal that I picked that one, but I picked that one intentionally. So you can click the green link there. There's an entire paper on Hugging Face that discusses the FineWeb EDU data set. And they analyzed it, you know, and so some data scientists analyzed it and said, you know, these are all the things that you need to curate to make this data set like really clean and really powerful and really usable with like the least amount of problems. And it's very fascinating, go ahead and read it. But what a data set in practice, what it does, you need to divide it into 3 different categories. One is training, right? Training data tends to be the most massive portion of it. And then you have a smaller validation data set. And so what you do is you use this training data, and then you go ahead and you look at the validation data and say, how far off am I when I'm training this thing? And the idea is that you use the validation data set to get it, to push it in the right direction so that it accurately captures what you're trying to build, in this case, a large or small language model. And then you typically, although it's not really super true in large language models, there's usually a test data set that just, you feed in test data and find out how far off you are, what is the confidence score, and how far off am I from the actual thing that I'm trying to train. So tokenization, right? Computers don't do text. So how does this actually work? So a tokenizer, all it does is it takes, there's actually many forms of tokenization, there's 3 of them, but what it does is it replaces words to numbers. And so the simplest example is this word piece tokenizer. It just tokenizes for every word, like the word like the or cat, and then it takes cat and it assigns it an ID, a unique ID, and that unique ID represents cat. And it doesn't need to know what cat is, it's just this ID. And anytime you see the word cat, it just references that particular ID. So it's just assigning a number to a label or text in this particular case. And those numbers end up becoming like the alphabet for your language model. And it's very important that you don't mix your tokenizers. So kind of like the computer science way of thinking about it is you have maybe a file that's encoded in UTF-8. If you save a file in UTF-8 format and then you try to read that file in Windows Unicode, that's not going to work well for you, right? It's going to look like garbage, and it effectively is the same thing for large and small language models. You can't mix your language. And it's also another much higher level way of thinking about it, like mixing Spanish and English. Totally different context, but you can't chunk on different tokenizers. So we talked about the data set, talked about the tokenizers, now the training process. So I kind of already alluded to it a little bit. So we train a model, we take that training data, and we go ahead and we test that training data against that validation data set. And then we basically say, hey, how far off are we from the answer? And then we adjust accordingly. So that adjustment, if you think about it, if we're training and then we need to adjust, we want that number or that adjustment to be as small as possible. Because ideally, in the best case scenario, if that adjustment is exactly we don't need to adjust at all, that means we've found our answer, so our adjustment is 0. So when you're training language models, you actually want that value to be close to 0 or near 0. The smaller the adjustment, the better your machine learning or your model is learning at a good learning rate, and it's actually doing what you are predicting it to do, right? Give you quality answers. And that is done through a loss function. So the loss function is basically, hey, I'm going to take the training data, look at the validation data, and then find out the difference. And that lower number, we're going to use the loss function, and that lower number is what's going to say, hey, this is what I'm starting to see patterns in the text and the data that is there for the language model, and I'm going to go ahead and say, okay, we're on the right track to building a language model that understands language. So now we've built, after we've trained our model, we have our data, we've done validation on it, and we're going in the right direction. Basically our loss function says that we're getting closer and closer to honing in on understanding the structure of the data set, which is effectively just learning a language. And once we get to the ability to say, hey, this language model can now understand the context or the domain of the data set, we're going to go ahead and save it. And that can be done in PyTorch checkpoints. That could be done as Hugging Face, Hugging Face binaries or checkpoints, safe tensor format. It could be, if you're using Onyx, it could be a bin format. So you just export it and save it so that you can run inference on it. But it's very important that as you understand that as you're training a language model, it's picking up subtle nuances at every step of the way. So it's understanding like the association between the previous word that came before it, the next word. It's looking at the context of that word in sentences, and then it's looking at that context in potentially even paragraphs, right? Depending on how you architect the thing. But at the end of the day, you have a language model that's been trained. You have, as you start to spit out the answer, you look at all the tokens that you spit out prior, you try to predict the next token, and then you append it, and it's effectively a list of tokens. And who here has heard about top K, top P? Okay, oh, cool. So if you have a list of next possible tokens, your ability to manipulate what that next token is using like top P and top K. And what those are, I'll just say really briefly. Top K is only show me the next 10, or the top K is only show me the 10 most widely used tokens. And top P is show me the, like, if you use like a top P of 10, show me the top 10 most probable tokens. So that gives you your ability to manipulate what the next token can be. So let's do a little review here. So we take text, we turn them into token IDs, we take the token IDs, and the goal is to generate vectors. We have this attention mechanism that says, hey, I can go back and look at all the previous tokens that I've generated before. I want to have run multiple parallel lanes for what I think the next probable token can be. And all of those lanes, I want to say which one is the top one, which one's the second one, which one's the third most probable, which one's the fourth. And then do it over and over and over again, right? Keep appending the next token to the next token to the next token. And so if you try to build out this large language model or the small language model, and you try to build it like a machine learning model problem, it actually goes really bad. And I knew going into this, like why this is, but I was just kind of curious to see how it would fail. And how it will fail is you will run out of memory on your GPU, because you're talking about a 10 terabyte data set, and you cannot possibly fit 10 terabytes in the memory for a GPU in this particular fashion. So typically a machine learning model, so not a large language model, just a strict machine learning model, you make a pass over the data multiple times. So if I'm trying to take 10 terabytes and do multiple passes over and over again, that's not going to work out well because it's 10 terabytes. So how do you actually go about building one then? So it's definitely a lot easier said than done. And if you're trying to build a GPT-style large language model, first, a single H100 is not enough. You will be there forever, or even an H200. I started with an H100 just to see like what would happen, and it almost immediately crashed out. Not enough memory, as you saw from the error log, because the data set's too large. So I had to switch to a node that had 8 H100s. And as you can imagine, this gets pretty expensive pretty quickly because I'm using 8 H100s. And if you go on to like DigitalOcean or Lambda Labs or whatever, you're talking about anywhere from $24 to $28 per hour for this node with 8 H100s on it. And because the data set is so large, it will take thousands of hours to train this small language model. So for the first demo, I obviously did not let it run to completion. And we'll see first, it's expensive, but we'll see kind of like what the effects of that, kind of like the fallout of that is. So we already know the data set is way too large. We can't do multiple passes over the data set and load it all into memory. So how do we take this FineWeb EDU data set that's 10 terabytes and deal with it? And so what you have to do is you have to changed to a streaming token data set. So this is actually the interface for Hugging Face. I actually intentionally use this interface where you can actually stream it directly from Hugging Face to feed it in a stream format to the 8 H100s to break them up, to parallelize the process. It's pretty interesting going about doing that. If you're looking to further speed that up, it turns out like the company I work for, NetApp, they deal in storage. So we actually offer a couple solutions to help enhance and speed up that process. But suffice it to say that since you're streaming this data set, you have to be able to dynamically break apart some chunk or some portion of the data for your training data, and then you have to dynamically, as you're streaming in data, have some of that data reserved for your validation data set, right? Because we've already kind of just said, you need training data, you need validation data, and you need test data. So you need to do, as you're streaming, you need to do this dynamically. And so now the problem becomes a little bit more difficult. And who's heard of like epochs? Like when you're doing machine learning models and you're training and you have 1 epoch, 2 epoch, right? So what that means is, cool. So that epoch, what it means is you're doing one complete pass over the data. And so when you go to the second epoch, you're starting the second complete pass over the data. Well, we just said that we can't do that when we're training a small language model. And so we can't use that method. So what you have to do then is you have to use a step method, which basically, because we're streaming that information, we're basically streaming it and doing it in a stepwise method. We're going chunk by chunk by chunk by chunk by chunk by chunk of the data set. And so we're effectively doing batch processing because we can't load the entire data set in memory all at once. So I abandoned, obviously, the naive way of doing it, which is trying to load it onto an H100 loading the entire data set into memory. That didn't work out well. So if we take that data set and then we have this tokenizer called tick token, it actually happens to be the OpenAI GPT-2 pair byte encoding tokenizer. They open sourced it. And we based on our data set, we create a vocabulary of 50,000 words, right? So each word becomes an int or a token ID. It's like flipping back and forth. So that becomes our vocabulary, 50,000 words. And we can actually also use the GPT config, which is also OpenAI's configuration for like a block size of 2K. So that's our look-back window. So our look-back window is our attention. Like how far back can we look for tokens? Then we have, this configuration also defines the number of layers. So this is our transformer block, right? How many things can we run in parallel? The head, which is so 32 different evaluations of the lanes. How can we evaluate each one to say which is the best one for the next token? Then we have the vector dimensionality. Each vector transitions to another vector, and we limit and cap it at 2K. And if you do all of those things, use that tokenizer, use that configuration, and then use the FineWeb EDU data set, you roughly get a 1.8 billion parameter model, which in today's world is sad. And it's so sad, I'm going to demonstrate it here right now. So you don't need to write any of this down. The code's all available on my GitHub. I'll show you the link to that repo at the end. You can do this at home. But to start off the training process, you can just go into the small language model folder, go Python 1_train 8x H100. That will stream the data set, do the training process, but it does require 8 H100s. And I stopped it at 10% of what is required. to actually train that thing to completion. And the reason why is it got ridiculously expensive. And I was footing the bill for it, for this presentation, and yeah, it was not fun. So I intentionally stopped it early. And by intentionally stopping it early, this is what the output kind of looks like. So just like any kind of language model, you give it a prompt, and the prompt I gave it is kind of like a story. And the prompt is, it's loading. I'm doing this on my local laptop, just to kind of prove that, and this is an M1, and I know like the M3 is got additional floating point calculation, so it's much, much faster, but I'm intentionally doing it on a slower laptop so that you can see that you can actually still load it in memory and run it. So we're doing a story, once upon a time in Long Beach. That's where I'm actually from. So I'm from Long Beach, just down South LA County, and we want the small language model to basically complete this story and give us, do the completion of our bedtime story. And this might take a little bit of time here. Once upon a time in Long Beach in the time of the year 1815, blah, 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 complete, utter garbage. And it's because I stopped it early. And yeah, it's absolutely horrible. So, and this is intentional, I knew this was going to happen. So, obviously, when you use a large language model, even a small language model like Llama 3, 8 billion parameter, you actually get a coherent answer, and this is definitely not it. So why did I do this? So a GPT-2, right, we're at OpenAI, actually 5.4 came out today, right? Yep. So even training a GPT-2, like version, small language model, is ridiculously expensive. It requires, if we remember that data, that Hugging Face data set, that paper, it actually requires 6,000 H100 GPU hours in order to train this model to completion. And if you do the math on that, the estimated cost to run this model to completion, which I'm not gonna burn 20,000 K to just show you this model and how it is, it will be 20,000 K per hyperparameter, which then gets you to the roughly 8 billion parameter model that you would typically see in a small language model. So what is the takeaway of this? No person in their right mind does this, right? Okay, thank you for attending. No, I'm just kidding. that would be hysterical. You have learned nothing. Okay, so it costs too much money. And the resource, 6,000 H100 hours is ridiculous too. So kind of the takeaway is there are very few people or companies or individuals that have access to the resources that do this. It requires a lot of resource, a lot of cooling, a lot of power, a lot of water. So that's because it's a hard problem to solve. And we're not going to play the video, but if you want the actual PhD version of explaining all of this, and actually what the code is based on, so who knows this particular fellow? Andre Kaparthi, awesome. Former OpenAI, former Tesla, and then I think he went back to OpenAI for a bit, and now he's starting his own thing. This is a 2-hour tutorial on how to do it in the PhD way, but I gave you basically the non-PhD way of doing it, but it's a really cool video if you're interested in it. And you don't need to take a picture of the slides are also in the GitHub repo too. So you have all of it. Okay, so I told you that's not the way to do it. How do we actually do it? And this is the recommended way. This is what you actually want to do, is you want to fine tune an existing model and impart the knowledge that you want to impart on it, and then optionally quantize it, which basically we'll talk about it in a little bit here. So this is a much easier way. Not only easier, but far more cost effective, and we'll kind of look at that. So what is fine tuning? So fine tuning is taking an existing model, and in our next demo, we're going to use Qwen 2.5, the 7 billion parameter model, but we're going to take a model that's kind of a generalist model. Now, if you just need generalist kind of language understanding, you can stop right there. You have all of these cool models that are available. You can just use it to understand the language of your choice. But if you want it to have some sort of specialized knowledge, then you need to, on 8 billion parameters, it probably hasn't been trained on that specialist knowledge. And that's the reason why a lot of people go to these massive, trillion parameter models, is because they've been trained on the world. But it's also very expensive to run on your GPU, right? And like GPU farm, right? So the alternative is to take a small language model and impart the knowledge, the pieces that you actually care about, and impart that behavior onto a small language model. And so that's exactly what fine-tuning does. We're giving it a new data set, we're modifying the weights on an existing model, and we're imparting that knowledge onto that model. But all of the mechanisms that I talked about, predict, compare, and adjust when we're doing the fine-tuning process, they all apply to fine-tuning as well. Slightly different process, but it's still the same thing. Predict, use the validation data set to push it in the direction that I want it to get, and then adjust as necessary to get it to build a model for your specialized particular knowledge. So the non-data science way of saying, think of a GitHub repo. You have a GitHub repo, a project, a probably cool project that you say, this is really cool, I would like it to do something vastly different. I'm going to fork that repo, completely change the behavior of it, but like most of the skeleton's actually pretty good, but I want it to do something else. And you want it to do that one else, that one special thing. That's exactly what fine-tuning does to large language models. Fork a repo, change the behavior massively to do one thing really, really well in particular. So who's here has heard about quantization? Okay, cool. So when you train a large language model or small language model, typically it's done using floating point 32. And the idea of quantization is, instead of using floating point 32, we're going to use different numeric representation, right? Because everything becomes an integer or a number, sorry. And we want to change the math of the problem to something that's much more manageable. So you can quantize a model that's using floating point 32, and you can quantize it down to like int 8, floating point 16, and then BF16 is this one special thing that NVIDIA does where, I always mess this up, but like the precision is less and the numerical value is larger. Anywho, it's a different representation of a floating point number. So why do you do this? So smaller memory footprint. Instead of using 8 bytes for FP32, if I'm using int 8, I'm using a fourth the number of bytes. And just by thinking about the math on that, you're using a fourth less memory, like 1/4 of the memory that you were using into int 8. And so you're basically effectively making the math much easier. Now, some CPUs or GPUs, well, some CPUs, they're not really good at floating point. So you convert the math to int 8, which every CPU on the planet knows how to do integer arithmetic, right, or manipulation. And so that's the reason why you change something to like floating point to like int 8. And that now you can run that particular model on commodity CPU hardware. You don't require as much memory to load. And that's the whole purpose of quantization in a nutshell. So I'm running out of time. So what doesn't change? So there's a bunch of things that don't change. You're starting with the base model, so all of the characteristics that you normally have, you still have all those same characteristics. So like the context window, the attention heads, the layers, and all that stuff. Fancy way of saying you're just changing the behavior of the knowledge that you're imparting onto that model. I'm going to skip this in the interest of time, but there are 3 methods for quantizing. The last one's really cool. I'm just kind of like lopping off, and I'm using the most pertinent. So you're kind of like lopping off and removing the stuff that's the least used or the least, just kind of like leave it at that. So because of the quantization process, before quantization require much larger memory footprint. You need a GPU. The inference speed is slower. and then the correctness is actually really high, right? Because you're using the full-blown power of a GPU. After quantization, the memory footprint's lower. Processing power, you might be able to get away with a CPU or a low-end GPU. The inference speed is much faster. And the correctness takes a small hit, but don't worry about that because it's not actually, if you think about it, because you're imparting specific knowledge onto that existing language model, that's what you care about, and that's kind of like you're pushing the weights in that direction, and you're removing the stuff that actually you don't care about anyways. So the process is very similar. Start with just a review. Start with an existing model, and in our demo, we're going to use Qwen 2.5 7 billion parameter. You have a data set, you fine-tune it, and then you validate it, and then you deploy it. So the model we're going to use is a SQL language, small language model that will understand how to generate SQL statements and understand SQL statements. So that's what we're building. Qwen 2.5, the data set is a database schema plus a question, and then the output is SQL. And so that's what the data set looks like. We're going to fine-tune it. There's a fine-tune strategy called LoRa, don't worry about it. And then we're going to quantize it down to int 8. So let's go ahead and take a look at that. If you want to do the training process, the fine-tune process, that's probably, you can see Python fine-tune, run that. It will automatically load the data set and start the fine-tuning process on Qwen 2.5. You want to quantize it, run quantize. It will take the final model that gets produced that now understands SQL. It'll quantize it down so that you can run it on a laptop. And we are going to run inference on it right now. Oh, shoot. Oh, Python probably doesn't work, right? Okay. So this is we fine-tuned the model. We've imparted the knowledge of SQL. And this basically, don't worry about the warnings and all that fun stuff. So we basically, as a part of our question, we're going to ask our new SQL language model. We're going to give it a table. It's a simple table, right? Create table, persons, or employees. And it's going to have like the person's name. It's going to have like their age or whatever. And we're going to ask it some simple questions. So the first one we're going to ask is list all the usernames in this particular employee table or this user table. And it's going to, because now our small language model knows and understands SQL, we can actually get, this is actually dynamically generated, right? This is the response from our particular language model. Select name from users. List all the names for users. Who is the highest paid employee? And so how would you write that in SQL? Anyone want to take a stab at it? Select asterisk from users, order by salary, descending, limit 1, right? That's like one way of doing it, right? Hopefully it will come up with that. Yes. So we literally trained a small language model that can answer SQL problems for us. Pretty cool, right? So that one, oh, right here. So the cost to train that model, $100. I think it was far less than that. I think it was like ended up being just under 100, or maybe it's just over 100. But versus $20,000, right? So if you need special special knowledge like SQL imparted onto a small language model, this is how you would go about doing it. This is a much better way, much cheaper, much more effective, and if you want to quantize it to run on commodity hardware, this is the way you go about doing it. And what's really cool about this approach is if you're starting with Qwen 2.5 and you need to iterate over your data set or your training, or maybe there's a new version of SQL that has new language statement or whatever, you can just rerun it and it's totally iterative, right? Start with the model, add the new data for the data set, do the retrain, and start that way. Real quick, because I got one other section. So the question was, how big was the data set? I kind of really did gloss over it. So it's a synthetic text to SQL data set. It's publicly available. I can't remember the size. I think it was actually on the order of, tens of megabytes. Oh, just click it. It was, no, definitely not terabytes. It looks like 32 megabytes. Now you know all the links work, right? So, much cheaper way of going about this. So, cool, we built a SQL language model. But it actually is this is the bonus section. There are actually many types of language models. It's not just the Q&A one that we're used to, where you ask a question and you get a complete answer, like, tell me the difference between a cat and a dog. GPT runs around and says, this is what a cat does and this is what a dog does, right? There are many other language models. And here are a small list of them. So there are language models that do summarization. There are language models that do code generation, which we just did, right? SQL, that's code. And our next demo is going to be this MLM. So it's a masked language model, which we'll talk about in a second. There are classifiers. But the idea is, if you have a particular specialized language domain that you want to impart onto an existing language model, you can teach it to do things. And I'll talk about one at the very end when we get to resources. But a masked language model, so who here, oh man, I'm gonna date myself here, right? Who here remembers Mad Libs? Yes! Right? You had sentences, you had blank spots, and you had to fill in the word in that blank spots. The idea is to make it super funny by picking wacky words, but you basically have sentences with a gap in it. Now, what a masked language model does is it actually, based on the sentence that you're providing it, it will actually guess the most probable word that should fit in that particular gap or that hole. And so that's exactly what a masked language model does. Now, there are a whole bunch of applications that you can do for it, like you can do extraction. I know that sounds weird. You can do classification using a masked language model. Basically give it a string and say, classify this. It should be blank, and it will analyze the sentence, and it'll give you the most probable classification for it. And there's also this question mark, and I'll tell you why that's there. But let's just get to the demo. So the last language model demo, we're going to do the masked language model. So just like before, if you want to train it, this does the data preparation step. This does the training, and let's run inference on it. And it's actually, this one's super quick because we're only trying to guess one word in a sentence. So the capital of France is blank. And based on that sentence, we ran it through our masked language model, and it said the most probable word is Paris. The capital of France is Paris. And then distilled models are the blank of large models. And then the most probable word is smallest, which is correct. So that's what a masked language model does. Pretty cool, right? So I'm floating the idea out there. You can do all sorts of wacky things with language, and there are many other forms of language models out there. This is one example. So, I actually have another session tomorrow. It's actually pretty cool. It's this one right here. And I'm going to tell you why I built that model, and I'm going to use it in this session right here. But if you're interested about doing side channel acoustic attacks for keyboards, so think keystroke loggers based purely on sound alone of when you hit a key on a keyboard, can you guess the letter that's being pressed just by the sound on it alone? And spoiler, you absolutely can. But if you're interested, check out the session tomorrow, 101, room 101, I think it's at 2:30. So resources. All of the code to build all three of these language models, I would recommend not doing the first one. If you want to burn a whole bunch of money, go for it. Otherwise, the two useful ones are the last two. But they're in my GitHub repo here. All the code to do the data prep, the training, the fine-tuning, quantization, and all that fun stuff is available in my GitHub right there. So why do we care about this? Why am I talking about this? Like, you've probably heard this tokenization explosion and the cost that's associated with it. The reason why we care about small language models and the reason why we care about quantizing them to run on cheaper hardware is that, if you think about OpenAI, they're losing, tens of billions of dollars a quarter or something now. And then I'm sure Anthropic is probably on there too. I mean, if they're losing money, you're getting your tokens on a discount right now. And imagine over time, you're probably competitors are going to drop off. And at some point, they're going to need to show a profit. And guess what's going to happen to the cost? Right? Do the math. So quantization and running small language models like on your laptop or on cheaper hardware, that's the reason why you do it, right? Cheaper power, you don't need as much power, cooling, inference, and all that fun stuff. I have a blog post about it, and I'm actually talking about using small language models in an agentic, multi-agent, agentic AI setting. It's actually in April at Open Data Science Conference East. NetApp, we do storage, and if you're looking to stream data from data sets to train your large language or small language models, we have a couple of solutions. You can use Kafka and all that fun stuff. I need to do the company plug so they will pay for my hotel room. But we do that, and I would highly recommend you take a look at it because it does help the training speed and cost like way better. But yeah, cool, thank you. I think we have time for questions. Yes, I'll try to repeat the question.
Losing any money other than the token you pay for the large language model. So how do you compare the fine tuning or the time versus writing that Python code agentic in a couple of minutes to achieve the same thing? So basically I'll summarize the question, like why fine tuning and why not just use a model that's yeah, well, agentic, who's that language model exists somewhere. Where does it exist? So if it's running on OpenAI, one, anything that you provide in the prompt, anything that you're providing as in terms of like embedding data, you're providing that to OpenAI. If you're okay with them having your data, go for it. Now, if you can run in your own like GPU instance, like an A100, you don't need to go for a huge H100. But if you can run that using like a NeoCloud or Google or whatever, but like run the model yourself in your own infrastructure, one, you have data privacy, which is huge, right? And then two, like, I guarantee you at some point in the next year or two, the cost of OpenAI is gonna just skyrocket, right? And if you can build out your agentic solution using models that you can run and predictably understand the cost of running that model, I think you'll be in a far better position, right? Because right now, there are people that are using like Claude Code, right? And I know people that are spending like $300-400 a week on Claude Code. And that's great. Like, trust me, I use it too, by the way. So I use Codex, I use Claude Code, but it's getting up there, right? Now imagine when they actually start to crank up the cost on all this stuff, and it's going to get far more expensive, right? Now, if you so in the Open Data Science Conference talk in April, it's that agentic AI talk. I forgot the name of the title, even though I wrote it. I'm going to actually take that the SQL model that we just built today, and I've already built a Python small language model so that it understands Python. And I guess the spoiler alert on the demo is I'm going to take those two models
and use an agentic, build out a small little agentic system so that says, hey, if I want to call a Python SQL, or if I want to call a SQL statement against a SQL, like MySQL or whatever, in Python, that is the demo that I'm going to show in April. But I can predictably understand the cost of both of those because it's a small language model that I'm actually going to run on my laptop, right? Versus potentially, you know, running into, I think there's many companies out there that are starting to run into like $30, $40, $50, $60,000 in token costs per person, which that's starting to get up there, right? So kind of the idea is run it on your laptop, run it in your own infrastructure. You can predictably understand the cost of what's associated with it, right? Yep. Any other questions? Question? Oh, right. Yeah, I don't know where the microphone is. I'll repeat it. Yeah, go for it.
So if I understand correctly, fine-tuning an existing model, it's kind of the same operation as training it, right? It's just that you're doing it on top of what is already trained.
Yeah.
Do you need to use the same loss functions, or can you pick a different one?
It kind of depends.
In another way, how similar does it need to be to the original training?
It doesn't have to be. Like, however you need it to be to have it impart the new knowledge on whatever it is, whatever domain it is. You don't need to know how the base model was trained in order to do the fine-tuning on your new model. And I guess I should also probably say, which might be the next question, is like, why do I fine-tune a model versus use RAG with vector embeddings? So I didn't cover this, and I probably should have. So why you fine-tune versus using RAG? So if your small language model, that's just that base Quen model, if all you need it to do is understand language, you can stop there. You can feed it data. You're not using any kind of specialized thing, like, you know, specialized domain like SQL statements. You can just have and use RAG, get your vector chunks, take the chunks, feed them into the prompt, and say, based on the vector chunks, tell me about the answer that you're, you know, sift through the data and tell me about the answer. So that's what a RAG pipeline is, right? I'm taking data, and I'm just having the language model sift through that data in order to find the answer within the data that I'm providing it. Now, a fine-tuned model, you're trying to change the behavior of the model, and that's the difference. That small language, if I started giving SQL statements to Quen 2.5, it would probably barf on me and say, I don't even know what you're talking about, or maybe, in the worst case, start to hallucinate something and say, I don't know, dog, cat, blah, 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 right? It doesn't know that stuff about SQL. So what you're trying to do is you're trying to change the behavior of the language model to say, I want you to know about SQL now. And that's the difference between the two.
Thank you.
Yep. Any other questions? I think we might be running out of time. 3 minutes, right?
Yeah, so based on what he already asked and partially already answered, you can run 7 billion parameter model on local laptops. And if they have jack up the price in next year, rather wait for the M3 or M2 to price to go down as the Apple come up with more, and use the whole model, 7 million parameter to run on a local laptop M3, by that time price will be cheaper. So why not use that approach? But as you mentioned, even that would be not as good as training it for the specific skill set what you mentioned. Is that correct?
Yeah, so okay, let me repeat the question. I kind of like to digest it. So like, why use Quen, like 7 billion parameter model versus like a whole, like larger model or a different model, right?
No. So you said you train it on a 7 billion parameter model and run it faster with the skill set. So if you don't do the skill set, wait for a newer version of that, maybe 9 billion parameter next year.
So like,
what's the?
Yeah. So I use Quen 2.5. 3.5 just came out a couple weeks ago. It still doesn't know SQL.
Oh, okay. So it's still, training is still worth it. Okay.
Yes. So even you have a new model come out, it's a very general purpose model, and it probably doesn't know anything about SQL. So even when that new particular model comes out, you still need to teach it SQL.
Okay, so in the follow-up question, so you can teach, even though it's dumb in answering SQL, you can teach the base model to have special skill set. That's what the whole point is. Okay,
You got
thank
it.
you. Thank you very much.
And then like the cool thing is, like because the training process is the same, when the 3.5 comes out, you can use 3.5 as your base model, rerun the script to train. Now you have a 3.5 model that maybe understands language a little better, but now also understands SQL a little better, right? Yep, cool. Anywho, I think that's my time, but if you have any other questions, I'll be outside. Thanks for showing up.
Yeah? All right, I'm going to get started in a few seconds. Last session of the day, yay! Yay, enthusiasm. All right. This talk is, I kind of wrote it for me because I'm a beginner in AI. I've only been using it 2-3 years. And one thing that struck me in talking to my clients about implementations of AI for their projects is that their perception of what ChatGPT or what AI or what it can do, what it actually does, what it can produce, is very different from my understanding. So I thought maybe to have a talk that's more like big picture AI, still digging into some of the maybe not math, but at least mechanics of what makes it tick, but also gain an understanding through mapping it to human behavior. Because a lot of the concepts of AI were spoken about before any LLMs were built. And a lot of what we now know as a marketing term AI, artificial intelligence, really was built for us as humans to understand intelligence equating to ours, right? We're basically mechanizing, automating, building a machine that mimics what a human would do. So I thought that maybe is a good lens into looking at what really AI is all about. Maybe without the word all, because it's very encompassing. I'll focus on some topics and hopefully have a conversation that resonates with folks who, like me, come to the area and say, yeah, I can see results of sorts, but I don't know what's going on. I want to know a little more what's going on. Anyway, that's how this talk was born. I'll just get into it. So the first thing I want to introduce is the intern. When I explain AI to some of my clients, I say, treat it like an intern. Tireless, enthusiastic, for sure. Went to school with good grades, read all the books, knows all this stuff. It doesn't actually regurgitate at you. It's intelligent. It's not like, oh, I learned this from the book, I'll just give you the thing. It's like it collected all of these words, but also in the same way that it doesn't regurgitate, but it does speak English somehow, it doesn't really understand what the job is about. It doesn't have an inherent understanding. It just has a vast knowledge of what was ever taught to the model, to the LLM. And it uses that in an intelligent way to satisfy your prompts, your tasks that you unload on it. So that's kind of an attitude slide, right? That's just kind of the mental concept of how things work is map it, yes, to a human that is just very, very enthusiastic, is armed with a bunch of words and a bunch of things that it was taught, and is eager to do the task you're going to give it. So let's take an assignment. Assignment number 1, write me a story. And let's start with a story that starts with the word once. What would enthusiastic do? Right? Well, it should certainly start with the word once, because that's what I gave it. Or rather, it should continue from the word one. If anybody ever heard of the notion of completion, that's all LLMs do, really. They are predicting the next thing after the last thing. The first thing they start with is once, so that becomes the last thing. Now, what can I complete? How can I complete the sentence? And if I completed a sentence, how can I start the next sentence and complete it until the story is told? So that is kind of the framework that it operates in. So you write down the word once, then you write words afterwards, and you repeat it until done. Yay, we have an algorithm. And that seems intelligent to us, right? Any writer, Mark Twain, started with the first word and put another word down and another and another and another. All right, but here comes the problem. What comes after the word once? Is it once upon a time? Is it once in a blue moon? Is it once there was a handsome guy on a stage at Scale giving a talk? We don't know. Fiction, all fiction. So what would the intern do? Well, it knows all the words. It's seen them all. It doesn't exactly remember the sequence, but something sticks with it. It's seen some words with probabilities. It knows that in all books it read, upon appears roughly 0.3 of the time, 0.3 out of 1. So all probabilities I will mention today are between 0 and 1, exclusive of 1. And once in, maybe 0.4, and once there, it's seen this kind of sequence before. It doesn't remember the sentence and will regurgitate the rest of the sentence, but it does know that after the word once, these are the likely words and these are their likelihood. Well, that makes the task really easy, right? It seems. What should the next word be? Well, in has a probability of 0.4, seems the most likely. Upon is at the top, so that might be an order thing. And there and upon seem to have the same probability. But what does it mean if it picked once in? If I told it tomorrow to write the same story, it should just say once in? And all stories ever told should be once in? Blah, 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 blah? That'd be kind of boring. No? What would Oscar Wilde do? Well, I don't know. He's dead. I don't know. But, it can apply different logic on the left column, by the way, if you're reading, of how to select the next word. Well, number one is just pick number one. Grr, the winner. Grr. Yes, great. Sounds robotic, sounds rigid, boring. Good for some stuff. If I were to code and I have learned all of the thing and I know the most probable thing after this is this, it's because of something. It's because all good code that I was trained on goes like that. So if monkey see, monkey do, I will get the result. Deterministic-ish. We can pick from the top K. We had 3. Let's say we pick from the top 2, 1 at random. The probabilities are probably close among the first 2, or first n, first 10, first something, right? There could be thousands of words with probabilities. I just showed you 3 because we don't have all day, and it's the end of the day. So there, I think, we can pick from the top contenders. Let's pick a number of contenders, 10, and at random pick from them. As we've seen at the previous slide, all the top 3 had fairly reasonably close probabilities. So the chances of me picking a word that is not good are kind of low. And that gives us kind of a consistent thing. Once upon a time, once in a lifetime, once there was a very handsome guy on stage at Scale X giving a story. So that could work. And it's good for general chat. That sounds kind of reasonable. It doesn't sound off the rails. It doesn't sound hallucinatory. It sounds reasonable. There's another method of picking, and that is top P. And top P, so top K is the second row there. Top P is saying, well, I could have a long list of words that might be reasonable. But if I just limit it to the top 3, I may be cheating myself out of the next word, which has also a very similar probability. So what top P says, oh, well, I have a list of words. What I'm going to do is I'm going to start collecting words into a bag until the probability reaches a number. Let's say P90 or so, until it reaches 90% probability. All probabilities together add to 1. So if I reach the 90 percentile, then I know these are good words. And then the rest not. But I don't know how many it will take. I just kind of iteratively collect them until I reach there. And there's a little feedback, I'm not sure. And then, you know, that's top P. It basically a softer, gentler way of doing things than top K. And that's a little more dynamic and a little more human because it gives us more nuance and more to pick from when probabilities are kind of not dominant. But if I have 1 or 2 dominant probabilities and the rest are kind of low, then I'll reach my P90 with a short list, and then it will be still feeling concise. So top P is, I think, kind of the warmest of them all among these. So these are kind of policies, and our intern will pick one of those methods. If you're creating your own implementation using an LLM hosted by whoever or by yourself, you'll be asked to tell the LLM, hey, with my prompt, what method do you want me to use to predict the next word? So that's good to know. And then there's another parameter that if you wanted to implement, they will ask you, and that's temperature. It's a little early in the talk, a little mathy. Temperatures are a divisor, that all of the, let's call them words for now, all of the word probabilities get divided by. So what it lets you do if you have your natural probabilities, meaning that you have just kind of counts of words, and if you divide the sum of counts of all words by the thing and do the fraction, then you have very big spreads among them. Well, you can lower the temperature, meaning de-amplify the spiky ones, the ones that are really high, and thereby kind of bring them to the same level. If you do that, top P stuff will collect more words. If there's a big spike, top P will collect less. So temperature and your selection criteria kind of play hand in hand to give you this very creative, seemingly thing where you have a lot of candidates, or less because the spikes will win. So when you hear about temperature, think about like bringing the probabilities to kind of the same level. With a low probability, a low temperature being very truthful, meaning it kind of less creative, it keeps the spikes up, and the high temperature means shave them down, not shave them down, scale them down in order to get a more nuanced or creative kind of way. That number is very relative. If you go and you pick a model on AWS and it's, one of them, and you pick another model that in a different LLM provider, that temperature will give you different results. So these are numbers you always twiddle with when you're implementing stuff because it's not universal. Cool. So we picked the first word because we were told, and we picked the second word because we came up with a good reason to pick the next one because of its probability, and now we have to predict the third one. And after the word once upon, there could be a time, right? But there could be once in a blue moon, lifetime. So those probabilities of the fourth word, let's say we all agree that the third word is a, once upon a time, once there, that's not a good thing, not low probability. But, you know, once upon and once in followed by a is very reasonable. But what is the next word? Well, that doesn't depend on the word a. It depends on the word that came before it, right? That's what we call context. We're not simply picking the next probable word. We are conscious of, we have this context, we have this memory of history of we got here somehow. If we just forget it and we just say, I don't know, I'm just zero memory, I'm Dory, I'm just swimming in the sea, I saw A, here's the next probable word, I look kind of crazy. And if I remember these things, it helps create the impression for us humans that it understands something. So that history, that context is extremely important. And when you hear, in the context of LLM, you'll hear of a context window, you will hear of token limits. They play hand in hand. Those are the limits of the LLM to be able to go back and kind of consider the past as it's predicting the very next word. So let's talk more about context. Generally speaking, inside the LLMs and the SLMs, which are just smaller, you will find an architecture that is somewhat like you see here on screen, where the user prompt comes in, and there's something called a transformer layer. And then the transformer layer takes the prompt and transforms it, changes it in some way. In comes something, out comes something else based on what came in. And then it tries to predict the next token, update the context, that memory of what was, and then feed it back, carry back that context into the transformer layer, or through the transformer layer, to be processed again and again and again until the story is told. So that's kind of the mechanics of most LLMs. They may use different techniques. They may have some math shortcuts. They might skip or add or embellish, but roughly speaking, your prompt goes through some layers, and each manufacturer, each person, each company, well, I guess the person, each producer of an LLM picks their own actual implementation and internal architecture. So let's talk a little about the transformer layer. So within the transformer layer, we do essentially two things. One is we take those words that existed outside in the mind of the typer, and you convert them into numbers. That is an internal dictionary that says every word ever seen in our training is going to be assigned a unique identifier. So the first thing we want to do is convert it into numbers. Why? Because words mean nothing to a computer, and numbers do. Now that number becomes somewhat significant because it's going to be predicted into. So, you know, if I have two different LLMs, the number getting assigned to the word once in one is not going to be the same as the other. It's just the mechanics of whoever created it, but they will make it in a stable way such that if you use that model again and again and again, every time it sees the word once, it'll get the number 0.917, and that's that. So token encoding is simply the action of taking the words that came in, they get tokenized. Tokenized just means separated from each other, split on the space, throw away the dots or don't. Different people do different things, but basically encode those inputs in their entirety into some tokens. And then there's an attention mechanism. Attention is a focus, and we'll talk much more about it, so I'm not going to jump too much into it here. Overall, what I want you to take from this slide is that as we go through and try to predict the next word, and the intern is just trying to figure out on their little tablet, what should I say next, the more there is to process, the longer the story becomes, the more the context is big, and the computations to produce the next one and the next one become large. Not only that, internally in the transformer, there's a lot of blocks operating in parallel, so when you hear about billions of parameters, it is literally like big blocks of matrices that contain a lot of data, and that computation, even on just one token, each time, each iteration through, is a big computation. So I said the word model multiple times. What is it? It has a parameter file that contains billions of numerical weights. So each, I don't know, it's not a token and a weight. Those weights are baked into those blocks that I'll talk about in a bit. It has a kind of a transformer architecture. I showed you the kind of simplistic one in the slide before that organizes how the prompt flows through the transformer layer, the whole LLM construction in order to produce a result at the end. And it has a vocabulary. When you first come in, all the tokens, all the words become tokenized into numbers. And then when you exit at the end, because the predictions are just number prediction, at the end, when it feels like it finished the thing, then it retranslates all of the output numbers back into words we understand. Internally, it just crunches numbers. It has no idea what the word once is, or ounce, or chair, or anything. It just has numbers. So that's where the vocabulary comes in. So the transformer has kind of two parts. One is attention. Attention is kind of like a flashlight. It helps the model find the relevant previous tokens. So as context grows large, I'm accumulating token. I'm dragging a bigger and bigger bag of thing. But what is really important? In Once Upon a Time, was the word "a" important, or was the once and upon more salient? So that's what attention attempts to do. Attention is a mathematical transform that tries to find which ones of the things in the context are important. And then the feed forward, the supply of the semantics, meaning in what context was once upon a time spoken, that is the more semantic part of it. That is the only part in the LLM that has some kind of notion of understanding, that it's associated to a topic. Not that it knows or understands a topic, just that it's seen these things before, kind of in the same area. Why do we need attention? If I talk for an hour and a half, do you remember every word I said? Right? In order to produce if I quizzed you, pop quiz, what did I say on slide 1? It's like, I don't know. Oh, you had the intern thing. Oh, I kind of remember that. That's kind of important here. So that's what attention is really about. That if I just pile on you big, long conversations, you kind of lose focus. But if you can kind of say, oh, these are the important key parts, then your answer or your interaction becomes more meaningful for us humans. Where are we? So the attention part is very significant. And how to find it mathematically is a subject for people who are way smarter than me. What I gathered so far is that internally it does essentially matrix multiplications. And that matrix contains kind of the latest prediction that you know they got. As I talked about enriching the context. And then it takes it and it tries to find mathematically which of the weights and probabilities so far are salient to be carried forward. And it does it in a mathy way that I cannot explain, not because I have no time, just because it's above my head. So we'll keep it there as a mystery, and if anybody knows better, I'd like to hear that talk. So several times I already said there's context, there's token limits. What happens when, oh my God, I just listened to a 3-hour conversation. I read a book with 1,000 pages. Even if I remember all the words, it's just soup. And the problem is that if you give me something important and then bombard me with a lot of narrative that is not important, at some point my brain explodes and I forget even the important thing. And that can produce things that look like hallucinations. That could produce security problems like, who was it? Recently, a very famous case. What happened is that this person told OpenClaw to go through the emails and do some stuff, and it told it, don't delete any emails, don't do anything. But the don't do anything got buried in all of the data that it went through, that it had to retain as context. And by the time it got to the end, it kind of remembered the first instruction, or didn't at all, and then just went ahead and hallucinated that it needs to delete the emails. So that's a big problem. How do I know when I'm listening to the barrage of things what I can retain and what I can safely discard? So there's a couple of ways to do it. One is that before I even go to process all of this context, I make it smaller. So if I had a way to compress it, then the amount of context is low and I'm less prone to blowing the context limits and it's more relevant. And there's two kind of ways of doing it. One is summarization, that you essentially like take a little model and kind of say, okay, well, I have a lot of story, but now let's just TLDR it for me in a nice way that I can read still. A human would look at it and say, yeah, that's a good TLDR. And that just gets rid of like a lot of noise, right? But still retains the essence of it. The problem with summarization, TLDR, yeah, you don't have all the nuances. We threw them away because we wanted to compress. So you get more vanilla, not so interesting, not so creative, not so insightful results when this is used. The second one is a little more technical, LLM Lingua. It passes through a model. It summarizes it internally. It's also a summarization or a compression technique, but it produces something that is less likely to ever be read by a human and still retaining somehow that context because it's very model specific how it does it. So that's one idea, is to compress things before it even went into the processing. The second is to do it later, meaning in the model. And that one is more mathy and more complicated, but the advantage there is you didn't throw away things you didn't process yet, you're throwing it while processing. So the KV cache pruning is just saying, well, part of the issue we had is we had used a lot of memory, and we can't just memorize everything forever. So we'll just come up with a way to retain the important words and then be able to evict words as we need, evict words that are less useful. And then gist tokens is another very binary technique that attempts to compress the data further into a thing that nobody can understand except for the LLM. So it achieves very high compression, but it's very difficult to debug or reason with because everything is like compressed beyond recognition. Anyway, internals. One of the interesting things, as I was reading about LLM Lingua, which is a compression, not a latent compression, is that when you're trying to figure out what is the next word, or what are, sorry, we're trying to figure out which words are important in our past so we can carry them forward, right? One thing would be hey, let's pick the most popular words, right? Because they're important, they're popular for a reason, everybody speaks them. LLM Lingua does the opposite, which was counterintuitive to me. What it does is it's trying to find the most surprising word. Because a surprising word is this element that kind of sparks our memory, right? This memorable moment is rare. The rarity implies some kind of importance. It piqued our interest. It has context that us humans like. So LLM Lingua works on this principle to pick important context by using the path of most surprise, not least surprise. It's calculating something called a perplexity, and the math behind it, again, a little above my head, but that's kind of the principle of operation for it. And we may think that feeding it forward and what I said so far is like, oh, you take the prompt, you pass it through the thing, you do a loopy-loop, you bring it in, and that's that. Well, for LLMs, they're called, that first L is large, in the large language model acronym. It means that it has a lot of large blocks, and there's also an amount of parallelism inside. When they build these models, they put in a lot of transformer blocks. The idea is that instead of saying I have one path for the data to just flow through, we're creating kind of a graph and architecture where we're processing massive parallelism across many transformer blocks, each one with a little different twiddle of what the parameters are. Think of a polynomial that is 100 factor long, and each constant c is slightly different, right? The first term to the n, the next term to the n plus squared, and n third, think of a polynomial, but have the coefficients all slightly different. And we're going to pit them against each other. We're going to run all of them all the time. And we're going to pick a winner out of it, and we're going to say, this one gave me a good result, so I'm going to take this one on this round. And, oh, that one gave me a good result, I'm going to take that one on this end. So we have a block architecture within the transformer that just has many blocks. Each block has its own expansion, activation, processing of the tokens, and finally contraction into your same internal token. And it's a multi-layer operation. So with that, and I think I went a little mathy and a little attention in this, and could be confusing, and the purpose of this talk is to develop an intuition around it, not a working knowledge that you can say, now it's clear to me, I'll just bang it out in Python and it'll be good. So I want to kind of cover the concepts of what happened there, and then maybe map it to how we perceive it. And the main complaint about AI is like, can we trust it? What about these hallucinations? So hallucinations are not really a model problem. The model doesn't suffer at all. We suffer. We interpret the results as hallucinations. We say, that's no good. I want a better intern. Like, no, the intern's perfect. The intern's great, seriously. It's just that we interpret their stuff without understanding what their life is about. And now that we understand that there's probabilities and they just pick, and they go through a lot of machinations and they know all this stuff, but they may pick a probability for a word that you didn't think of picking, and from there they just ran with it and continued picking things, and now the result is like total garble or a really weird story. So, you know, the different reasons for this idea of hallucination. One of those hallucinations is, the reasons for seemingly hallucinating is that the intern would say, well, you know, I had all the books in the library, but I didn't read them all, it's too long. Simply undertrained, really. And if the intern wasn't trained, they don't have probabilities for certain things, or they have different probabilities than what they would have had if they read the whole assignment, and therefore it produces lackluster results. Other reasons for hallucination is it just made sense at a time. It saw probability, it was 1 atop k, ran with it. It produced something. In the real world, it could have maybe been read somewhere or something, but maybe not. Remember in the first slide I said they do not remember full sentences. They just remember probabilities of a word giving the word before it. So those kind of fabrications come from the fact that it is a stochastic model. It picks at random from the next possible token, and that pick may lead us somewhere that is not what we would have wanted. Next, oh yeah, I forgot. If the context is too big, if the physics of, you know, the model with all of the billions of parameters, all matrices of size, whatever, if we've exhausted those sizes, things kind of clear out of the KV cache, things get forgotten, and now it's like, oh, yeah, you did say that maybe, but I kind of forgot as I was working through it. So when you hit your context windows, you will get garbage, and sometimes destruction if you let it control your operating system and delete your files, as you can read on Wired. The next one is you kind of get the excuse of I got distracted. I got distracted, human. What it translates to in LLM speak is the fact that you may have given it parameters allowing it to look at low probability tokens, and it started chasing it down, and it wasn't the best attention maybe. And then you also get, I don't have a good explanation from the mechanics of it, but you also get the confusion of terms, which is to say, when we think of like, oh, context, we're always assuming that us as humans, the recent stuff we really remember and the furthest stuff behind we don't. Therefore, we kind of concentrate on the most recent. And it seems reasonable. You're kind of living at the edge of your attention kind of sweeps aside. But sometimes we see that older context get mixed with very new context, right? Like, here's $10, please get my boring list of items this, and also buy candy for yourself. They heard the here's $10 and they heard the buy candy for yourself, right? That's kind of the mixed context stuff. And that happens again because of the mechanics of attention, because of the mechanics of how we decide what is relevant, may have picked some stuff and compacted it into the context and discarded the rest. So to us as humans, it says like, dude, you didn't hear the whole middle part. But to them, it's like, I paid attention to the important things and I did my best. So this is all internal LLM thing. But we also have other techniques we hear about, RAG, for example, retrieval augmented generation. RAG is not an LLM and AI thing, it's an algorithm around it. RAG, when we hear about that, simply says, hey, instead of generating a prompt that is just what I, as a user, asked the GPT, I'm going to take that prompt, but I'm going to also pepper it with important information. What is that important information? The model was trained a year ago. It didn't know about what happened last week, but I have a database of news from yesterday. So if I take the question and then go to the database, find news articles that are important about yesterday, plop them together with my prompt, it really becomes this, hey, tell me about the latest news, and by the way, here are the articles. And then it can say, oh, here, I can process this one, right? But otherwise, the LLM doesn't know everything. Why wouldn't it know? Because it was trained long ago. Because the data you want to augment your query with is private company information, not available to whoever trained it. So RAG was, and still is, a very useful technique for overcoming the challenge of the LLM doesn't know about your company or about something really recent. Freshness and secrecy, I don't know, privacy combined. So that's the RAG technique. It is not a different LLM. It is not something that is AI inherently. It is prompt engineering. It's on-the-fly prompt engineering that enriches your user query with stuff that's important in order to answer a question. Very powerful. If you cannot retrain / it's called fine-tune a model because you don't have the money, the know-how, the patience, the time, then RAG is very, very useful. RAG underneath the scenes, under the hood, always, in my experience, always used vector search. Vector search is a way to transform text, just like I told you in the beginning about encoding and stuff. It transforms it into a vector, creates a vector, which is just a bunch of elements, a bunch of numbers, and then goes to a database where all of the, say, news were already encoded with vectors and just says, hey, which one is closest to this vector? Why saying vector? What's the importance of vector? Well, in RAG, there's something called an encoder, which is also a trained model, but it produces embeddings, not generates. Those embeddings capture semantics. They understand that white horse is not the same as horseshoe. It understands that, you know, a mouse in a context of like, I need battery for my mouse is different than a mouse as in the mouse ate all my cheese. So these kind of semantics are embedded into those vectors, and that way when we look for other things with relevance, we say, hey, the one with the closest vector to me is probably meaning the same thing, therefore it's relevant, therefore I'll take it. I'll take the articles about the mouse ate my cheese, and now I can tell the LLM, hey, now tell me about why did the mouse eat my cheese, because I have articles about it. So that's the general idea there. And another tool that, again, is not LLM, it's external, it's an application, is agents. We hear about agentic a lot. Agent let us do a bunch of things. They let us divide bigger problems, have the intern coordinate other work to be done. The other work could be other interns doing just generation, but very focused on a piece of what I asked it to make. It could be like read my email, so agents can talk to tools and say, read me some proprietary information, information off disk, look at the flight schedule, blah, blah, blah. And it can also perform an action. So agents are also a way for the LLM to reach out of the realm of my screen and actually affect something in the physical world. So agents are a very powerful thing. With power comes risk. but it is a way to extend the capability of the LLM from just generating one thing on screen to doing things in the real world, to do things in parallel, to do things faster because of that, or to handle just way more if we can cut our problem into pieces and hand them to agent to do independently. Agents internally are just an application. They are not an LLM. They're not requiring a new LLM. All model builders build models that can use tools. And things like LangChain lets you integrate and build agents fairly quickly and easily. Roughly speaking, the LLM is given an instruction saying, hey, here's a bunch of tools you could use, and here's what they do. So when you consider the input, please look at the list of tools, and if they're useful to you, feel free to invoke them. And if not, just don't. And that's roughly the instruction plus a user prompt, and it does the same because it now has this ability to activate those tools. So with that, we zoom back and we have the big picture. We have an intern. We give it a task. Is the task kind of conversational? Well, if it's conversational, we can go directly to the LLM. That's here. Also here. Directly to the LLM. Conversational stuff, you talk to an LLM, it's been pre-trained on some information. Different LLMs have different things, right? Some of them were trained on books from a library, some of them were trained on SQL code, some were trained with who knows what, right? Medical, legal, blah. So they may have many flavors. They may have many sizes. You know, you hear about LLMs, SLMs, you hear about billions of tokens, less billions of tokens. All available. Then if we want to have better generation, quote unquote on the better, I guess, because what is better? It's what we judge. We can have better generation through RAG, which lets you focus on things because we take the query and we dig relevant articles to what the query was about. So it lets it focus on that instead of being generally you carry the whole library in your pocket. You're really focusing on that. It can access internal data. Again, you know, ChatGPT didn't have access to my internal company documentation, so I can do that with RAG. And fresher data. ChatGPT was trained a month ago. Well, 4 or 5 just came out, but you know, a month or 2 ago, it will be a month old, and I have maybe fresher information, so RAG is really good for that. Another way to better generate is to use purposefully trained or tuned models. Those are models that are trained not just on understanding the general English and literature and stuff like that, but also some very proprietary or specific information, such as how to code, medical information, legal information, news, things like that. That's all textual. And then it could be trained to do things like generate an image or a video or audio. So those are specialized models. They work the same internally. They would just take a picture, convert it to tokens, do the transformer blocky thing, blah, 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 blah. Same thing, just different inputs and outputs. Mechanically same. And then finally, for complex tasks that you just can't go to an LLM directly or to an LLM through dynamic prompting, you can have agents, and that lets the intern operate more as a coordinator of tasks, launch different agents and use capabilities to achieve something, like booking a flight is algorithmic. There's a tool to do that, and the agent can talk to it and operate it. You can have another agent working in parallel, so the ability to cover much more complex problems is much higher. Yeah, so that is the big picture. I guess treat your interns well. I think that the enthusiasm of of LLMs always reminds me of just somebody who's eager to do things, well-educated, somehow doesn't seem to really understand what the real work is about, but is able to continually do it. And I think that's a very good mental model to think of it. And finally, this is, very, very high level, and math underneath this is very complicated. I don't understand at all. But also, some of what I showed you today will be obsolete 2 years from now. The construction and architecture, if you listen to AI news, it keeps evolving in very, very rapid way. People achieve a lot more with a lot less by being clever about the math, scaling down numbers to use 8 bits, doing sampling, doing all kinds of crazy stuff, and getting very good results. But that's all I had to say, and I'm happy to answer questions if you want, or whatever. Yeah. Any questions? Any comments? Everybody's lost the context window. Yes? I can. I don't think I have, but I think Scale has a place to put it. I'll definitely put it. And if not, just come to me and I'll email it to you. Yeah. Yeah. Thanks. Yes? I can barely hear you. You were reading a paper, and there's a microphone.
There's a microphone. I don't need to enunciate. Okay. So I was reading a paper somewhat recently about something called H neurons, and the idea is that you were talking about the hallucinations a little bit, I think, and the idea was that that there are neurons that the model will go through that light up when it usually would hallucinate, and those actually are related to the neurons, or related to the agreeableness of the model. So, its desire to say yes to you, basically. So you were talking about how it's like an intern that always says yes, and so they were saying that for it to be more factually correct, you would turn those neurons down, and if you turn them down, then it's less agreeable. So it's interesting because its want to help you may actually go down as it becomes more factually correct.
Yeah. First of all, thank you. Very interesting. I think this, again, shows the language that the gentleman used is a language of neurology, which kind of makes me feel good that this is all about us humans understanding better about what we consider intelligence, what we consider thinking, and how we may go about understanding how our own brains work. And what I showed you before that was called a perceptron, that is a term, from biology, and those neurology ideas of neurons firing, and then, maybe some areas of the brain activate this and others. I am not aware of work that shows areas in the multi-level, tournament that is the layers there, but certainly that seems like a fascinating area to look at, because we as humans have areas of our brain that have kind of the same chemistry, but they take care of different concerns and they do it focused. So that's interesting. I love it. Yeah.
Just had a clarifying question. You said that for AI agents, they're standalone, but for LLMs, they coordinate with them. So, for example, you have an AI agent, but then something like Claude is the actual LLM that coordinates with the agent?
Yeah, exactly. So when you look at, am I too far? Yeah, when you look at an agent is, and could be, Claude itself could be considered an agent. It's an application that is capable of taking prompts, activating tool as needed or not, or just using the knowledge that's baked into the LLM there, and having a multitude of them working on a problem. So you will be creating an AI application that talks to a multitude of them. So agents themselves can become a tool to an Uber agent above them. So it's kind of a tournament arrangement. But this whole idea of agentic is not an LLM. It's not the brain. It's the instructions the brain is given and whatever the brain already knows, plus tools that it can interact with, such as read your disk, format your drive, book a flight, turn on the light. Yeah. All right, one or two. I'm happy to stay until 7, but you tell me. Yeah. Yes, please.
Can you go back to that slide where it said, what would Oscar Wilde do?
Oh, okay.
It's that one slide threw me for a whirl because we always think an AI is like well, they're tools. Okay, yes, they are. How would they help us? But if I go to the bottom there of creative writing and storytelling, it hit me that like there's if I go to the way other side of the spectrum where it's like I can really like the question is how far can I extend this hallucination to be very creative but like in an interesting way? So are you acquainted with this book Finnegan's Wake by James Joyce, this novel?
I'm not familiar with that. I think I understand your question to be, and first of all, I want to say something about hallucination and creativity.
Uh-huh.
In my mind, I map hallucination to the realm of errors and creativity to the ability to produce something that is useful, yet maybe something somewhat unpredictable. And I think part of what you're talking about is like, oh my, can I just like amp the, like why, we're so focused on like making things so concise and predictable and good. Creativity is like, dude, just make the music and invent something new. And if we can just amp up the creativity, then the model can just help us like totally blow our minds. And I just wanted to note that, creativity, hallucination, two different things. Creativity is about how likely am I to pick something of very, very low probability relative to the others and continue to generate from that and come up with something coherent. It doesn't have to be like correct, but it has to be coherent in some way for us to really consume it and say, yeah, it did something good for us.
Right. Well, not necessarily doing something good for us, but maybe interesting in the sense that, like, there's in that book Finnegan's Wake by James Joyce, this Irish novelist, he published I think in 1939. It's nearly unreadable because it took him like 10 years to write it, but he's writing in this like dream state where you're mixing like memories and places and it's like hallucinations and but he's taking from various languages and dialects that are ancient, some that are obsolete, but languages all over the world. He's creating his own idiom, but he's writing in a form that's like it's not chronological. It's mixing characters and places and memories, like how you would hallucinate,
right?
Like in a dream. But he's writing that in a meta way. There is coherency there in a creative way in the book.
Yeah.
So I'm wondering in the future, of course not now, but do you think that level of like meta context could be created by an AI, or is that too much of a stretch?
Okay, so I'm not a AI predictor of the future, but thank you for the question. First of all, I want to note again, mapping to humans, we have poetry, we have prose, and we have storytelling, and when we have scientific writing. Those are all forms of expression with different purposes behind them. In prose, we combine poetry and word arrangements that do not necessarily map to our everyday speak, but expand our mind and resonate with us in some ways. Something that is like the dream, that seems like hallucinatory or LSD-like, it doesn't mean it's not human or we can't understand it, we still have access to it because those are patterns that we recognize as language that evokes emotions or brings thoughts to our mind. So it's all on the table. As of today, you can take James Joyce's and take Larev and feed it and fine-tune an LLM, and guess what? It's going to produce more like that. But if the probability of a word was 0 in the trained set, it's not going to get picked. It has to have seen stuff. All models are trained on things they have seen. They're not going to take a random word from the vocabulary. They're going to take a random word from all probabilities of I've seen this before. So that's where maybe, maybe not. I don't know if you're going to get your effect, but you're going to get some effects that are very close to it. Yeah. Yes, the last one, I guess, because people are already antsy, but last one on speaker, and then we can talk more. Yeah.
Hi, yes. In that slide you had with the RAG and the LLM, it seems to me like you...
Yep.
Yeah, it seems to me like the calculation there is, and my assumption there is the RAG tokenizes it and then into a form where it can be joined with the LLM's result, so it can be
sorry, that's misleading. So in RAG, what we get is that the query you submit, hey, what's the news yesterday, gets created into an embedding. An embedding is a separate model that always encodes into a same vector. It takes how's the weather into vector with 1, 2, 3, 4, 5, and how you doing into 1, 5, 4, 3, 1. You know, always the same length vector, and it just encodes it in there. Those vectors have a special kind of spatial property that they project into the space where semantic meanings that are the same are in the same region in the n-dimensional space, and things that are further away are in a different part of space. Therefore, mouse cheese live here and mouse battery live here because one of them was that mouse and battery are in the electronics realm and the cheese is in the food realm. And it's n-dimensional space, so it's hard to visualize, but in two-dimensional space or one-dimensional space, imagine, you know, I have a spoon, a fork, a knife, comes a spork, oh, somewhere between the spoon and fork, right? That's what Wally did. So, yeah, that's kind of how it works there. And it's not the same model that is the LLM. That happens before it's fed to the LLM. It's just a pre-step, takes the query, converts it into what's called an embedding. It's just a vector. And that vector gets compared to all other vector you pre-computed on the document. So that's a fast way of looking through the database, because you don't want to read every document and every word. You want the semantic meaning captured, and that's what the embedding model does.
Looks like there's a lot more research I'm going to have to do to understand it, but thanks.
Yeah, this is all very off-the-shelfish. If you use, let's say, MongoDB Atlas, they have auto-embedding. You just give it your documents, your news, and they auto-embed for you, and then you feed it a query, and they auto-quantize and do the thing. Yeah, those are all available. Yeah. Yep, the closest in space. Yeah, they're doing a dot product close nearness or a Euclidean nearness or a cosine nearness computation, but conceptually the closest one, yeah, or the closest ones, yeah. I think I'm going to stop just so that everybody could feel free to get up and do their thing, but if anybody wants to talk after, I'm happy to do so. Thank you so much for coming.